Dear student, welcome to ESE Online, digital platform of ESE Engineering Academy. This is Dr. G. Balaraju, Professor of Mechanical Engineering. In the present session, we would like to present the detailed video solutions for ESE 2022 paper 2. That's a technical paper. Okay, before presenting these solutions, I would like to show the weightage. I have given a slide, so where you can see the comparison. In thermal engineering, so this year we had 29 questions. So many questions were lengthy and some questions are very typical. But however, you can skip those questions. Just like you have to choose the right question. And coming to heat transfer, so there were 10 questions. All those questions are very easy and you can answer in comfortable manner. And in fluid mechanics, so there were 25 questions and a few questions were lengthy and some were typical. The remaining questions, of course, easy. And in renewable energy sources, so as usual, 12 questions. So the questions are easy to moderate. And in engineering mechanics, normally we used to get 6 questions. Those questions are you can manage comfortably. In strength of metals, there were 9 questions. All those questions are easy to moderate. And in engineering materials, so we had highest weightage at 12 questions, and those questions are easy. In theory of machines, there were 13 questions, so easy to moderate. In machine design, so the questions are lengthy. So maybe I can say tough. And maybe 11 questions, so the 5-6 questions are lengthy and tough. So those are actually conventional, they converted into objective. In production technology, like a 7 questions, like generally we used to get 6 to 7 questions. This year also 7. In IM and OR subject, 3 to 4 questions. Of course, we had only 3 questions. In maintenance engineering, 1 question. Mechatronics and robotics, so 12 questions. So these questions are easy to moderate. And you can solve this paper in comfortable manner, provided if you select the right question. So without wasting time, so my colleague will continue, and we have the detailed solutions. So my colleague, Strength of Materials faculty, will discuss the detailed solution for Strength of Materials.
Hello everyone, myself Hazrat. Now we will see the questions from Strength of Material. Total 9 questions came from Strength of Material and all are pretty easy. If you can attend our lecture, you can able to solve everything, my dear students. Now coming to first question. Centroid of a body coincides with center of mass and center of gravity if the material composing the body is the straightforward, guys. If the material is uniform and having the same density throughout the body and it is a homogeneous body, then we can say the centroid, center of mass, center of gravity, all 3 coincides, my dear student. Next, coming to second question. A cast iron pipe having a 750 mm diameter, it is used to carry a water under the head of 60 meters. Look at here. Assume this is a pipe is there. This pipe having a head of 60 meters head. So because of this one, water will be flowing through the pipe. When the water is flowing through the pipe, it creates the pressure. Because of the pressure, stress will be generated, yes or no? Now my question is, he want to limit the stress to 20 megapascals, then what is the approximate thickness of the plate must be? Thickness of the plate must be, guys. Look at here. The straightforward problem, guys. Hoop stress equal to how much, guys? PD by 2T. Must be equal to, as given that the maximum permissible stress is what? 20 megapascals. Now substitute, guys. P equal to how much? Gamma H. Gamma equal to how much, guys? Is asking us to take specific weight is 9.81. Take it, guys. Gamma H 9.81 into 10 cube. Head equal to how much, guys? 60 meters is the head into 60 meters multiplied by diameter. How much is diameter is given? 750. 750 by 2T, 2 into thickness, multiplied by 20 megapascals, multiplied by 20 megapascals, guys. So into 20 into 10 power 6 Newton per meter square, guys. You will get the answer T equal to how much approximately, guys? 11 mm. Okay, the answer is option C. Now coming to next question. A 20 mm wide and 10 mm thick steel plate is, look at the problem, guys. There is a steel plate which is bent like this. If it is bent like this, they have given that radius of curvature R he has given. He has given the R equal, how much he has given, guys? 8 meters. He has given 8 meters. Then he's asking how much moment I have to apply. How much moment I have to apply to bend this steel plate to have a radius of curvature 8 mm. It's a pretty straightforward formula, guys. That is what? E by R, M by I, F by Y. Or I can write sigma B by Y, my dear students. Now he has given the R. I can directly make it, guys. M equal to I by R. Direct formula substitution. Substitute the value of E, 200 gigapascals. Substitute the value of I equal to how much, guys? BH cube by 12. And substitute the value of R. If you substitute all these formulas, guys, approximately you will get the answer 250 Newton meter. Directly formula substitution, guys. Okay? Now, coming to next question. The pretty easy question, guys. A simply supported beam. There is a simply supported beam having 8 meters length, having a point loads of 8, 4 and 12. 8 at a distance of 2 meters, 4 at a distance of 5 meters, next 10 at a distance of 6 meters. The question is asking, sir, find out support reactions RA and RB. Pretty easy, my dear students. Simply using equilibrium equations, I can able to find out. That is what? Sigma Fy equal to 0. If you just make it sigma Fy equal to 0, RA plus RB equal to how much, guys? Downward forces, how much? 22. Now take moment about A. If you take moment about A equal to 0, how much I am going to get, guys? RB into, how much, sir? RB into 8 must be equal to 10 into 8 plus 4 into 5 plus 8 into 2. If you substitute, guys, you will get RB approximately 12. You are going to get, when RB equal to 12, RA must be how much, guys? 10. So pretty straightforward answer, guys. RA is 10, RB is 12 kilonewtons. Okay. Now coming to next problem. Which of the following is not used as a support for the beams? Pretty straightforward question, guys. We can use roller support, definitely. We can use hinge support, definitely. We can use fixed support, definitely. We never use independent support. Here, right answer, here answer is what, guys? Not used. Understand? It is not used. So answer must be what, guys? Independent support. Now, coming to next question. So one of the beautiful question of entire strength of metal questions they given in the ESE, guys. Beautiful question. He has given that, observe, read the problem carefully, guys. The given is a kind of overhang beam. To please, sir, read the problem meanwhile. Overhang beam having a length L and the center, how much load is acting, sir? 2W load is acting at the center. Okay. Now, at the end, what is happening, sir? At the end, some W is acting. This length equal how much? L by 3 has given. This L by 3 has given, my dear students. Then is asking that what is the net deflection at the center? Net deflection at the center equal to how much? What we can do? Again, we can use with the help of method of superposition. With this, now understand, guys. Now assume only 2W is acting. This 2W will give you downward deflection like this. Next, this W, sir. How this W will give you, sir? Observe carefully, sir. This W will give you deflection like this. SR, no? Upward deflection. But how the deflection is coming? Force into L by 3. Just transfer this force here, sir. Just transfer this force. W here. This is the W here. How much is coming, sir? M. M equal to how much? WL by 3. Here also, M equal to how much? WL by 3. Now substitute. This will give you upward deflection. This will give you downward deflection. So total deflection equal to, observe carefully, total deflection equal to WL cube by 48 EI. That is 2W into the length between these two is L cube by 48 EI, downward deflection, minus this will give you upward deflection. How much, guys? Same thing, ml square by 8a, straightforward formula, guys. ml square, m is what? WL by 3 into L square by 8ei. So how much we got it, guys? WL cube by 24 ei, WL cube by 24 ei. Net answer is how much, guys? 0. This is the only little time taking question. Apart from that, everything is very easy, guys. Now coming to next question. The maximum bending moment at a fixed end. They are given this question like this. Straightforward question, guys. There is a UDL load is there having W Newton per meter, having length L. Then he's asking what is the maximum bending moment. How can you find maximum bending moment, guys? Tell me, sir. M max equal to how much, my dear students? Force into distance, right? W into L into how much? L by 2. W L square by 2. The answer is option A. Okay, next. A spherical vessel has 1 meter diameter. Observe carefully. Diameter is given as 1 meter. It is subject to internal pressure. P is given as 1.5. Then he's given that the maximum stress should not exceed to 200 megapascals. Take care of the units, my dear students. And joint efficiency is given 80%. Joint efficiency is given 80%. Then thickness of the plate equal to how much? Again, straightforward formula, guys. That is sigma h equal to how much? PD by, understand, spherical vessel. PD by 40 into efficiency of a joint. Must be equal how much, guys? It should not stress beyond 200 megapascals. Substitute everything, guys. 1.5, take care of the units, into diameter 1000 mm. Take diameter 1000 mm by 4 into thickness I want. Efficiency how much, guys? 0.8 efficiency equal to 200 mm. Approximately we will get, guys, here thickness equal to 2.34 mm. Take care of it, guys. Option D is the correct answer. Now coming to next one. This is a last question, guys. A material he has given that modulus of rigidity. G is given, guys. G is given. And bulk modulus is given. K is given. Then the Poisson's ratio equal to how much? How can we find out, guys? What is the connecting point here? Simple formula, sir. E equal to how much, guys? 2G into 1 plus V, that equal to 3K into 1 minus 2V, my dear students. Substitute these formulas. 2 into G equal to how much, guys? 0.4 into 10 power 5 into 1 plus 0.3 equal to 3K. Sorry, I want to find out V, right? 1 plus V, that equal to 3 into how much, guys? K. K is 0.75 into 10 power 5 into 1 minus 2V. Here unknown is only what, guys? V. From this, if you substitute, guys, you will get the V equal to approximately 0.2736. Ultimately, what I want to say, guys, if you can attend our lecture, you can solve all the questions, my dear students. Thank you so much, guys. Next, our material science faculty, Madhushekar sir, will take care.
Right. So I'm Madhushekar, faculty of ACE Engineering Academy. Now here I'm going to deal with material science of ESE 2022. Now, especially from this subject, 12 questions were asked. 12 questions were asked, and these 12 questions are very easy and basic fundamentals. And this is the first question, the statement question here. The statement 1 is given, the percentage elongation is assumed to be based on gauge length of 2 inches, here it is given. don't confuse. 2 inches unless some other gauge length is specifically indicated. Generally, gauge length is preferred 50 mm. This 50 mm is nothing but 2 inches. Okay, na? So the statement 1 is correct. And the statement 2, if you consider, theoretically a material is considered ductile if its percentage elongation is greater than 5. Yes, it is also correct. If the percentage of elongation, if it is less than 5, then that material is a brittle. If it is more than 5, then that material is a ductile. Generally, if I consider a steel material, especially mild steel, the percentage elongation is 25 to 35, like that. It is going to vary. So the basic definition. But if you consider statement 1 and 2, the statement 1 is given about the gauge length. It is related to gauge length, and statement 2 is given about the ductility and brittleness. Is it material is a ductile or brittle? So both are related to percentage elongation, but statement 1 give information about gauge length and statement 2 gives about ductility. That's why both are right, but it is not, the statement 2 is not correct explanation for statement 1. So I'll give you the answer. Most probable answer for this question is B, because statement 1 and statement 2 both are correct, but statement 2 is not correct explanation for statement 1. Right, now the next question, it's a very simple question. Which one of the following alloys is most suitable for application of bearings, piston rings, bushings and steam fittings, gears? Generally, by using this word we'll guess the answer easily. Bearings, especially Babbitt metal we will use, or white metal we will use, that is nothing but a bronze alloy. Bronze alloy is a copper alloy, okay? Bronze alloy is a copper alloy that is having 88% of copper and some 11% of tin. That's why we call it as a tin bronze. So the most appropriate answer for this question is B. The most appropriate answer for this question is B, right. Now the next question. In general, annealing is carried out. It is a heat treatment process. Annealing is a heat treatment process. In this process, we are heating the material up to above upper critical temperature. After that, we are cooling the material in a furnace. It's a slow cooling process. By cooling the material with a slow cooling rate, we will get a coarse grain structure in the material, and due to that coarse grain structure, ductility and meshnability of the material is increased, residual stresses are relieved, right. So material become more soft, right. Material become more soft, so softness is increased. But increase in stresses, residual stresses are not going to increase, residual stresses are going to decrease. Ductility of material is going to increase, so it is also not correct. And decrease in toughness, no, it is also not correct. With increasing the ductility of material, the area of stress strain curve increases, so toughness of material is also increases. So for this question, the most appropriate answer or correct answer is A. Right. Now the next question here, consider the following statements related to compute the equilibrium concentrations of two phases. Right, here it is, this is the question related to phase lever line, you can say. So a tie line is constructed across the two phase region at a temperature, at the temperature of the alloy. For example, let us take a copper nickel alloy. For example, I'll consider a copper nickel alloy. Okay, now here I am considering 100% of copper. Here I am considering 100% of nickel. Okay, I am increasing, the x-axis represent chemical composition, that is percentage increase in nickel, and the y-axis represent temperature. Right. Now the graph, the phase diagram for this copper nickel alloy is this one. Now if I consider the lever line, for example, let us take the lever line is this one, that is a horizontal line. So first of all, lever line is an horizontal line drawn in a two phase region. In this region, liquid is there and solid is there. So the tie line is nothing but a lever line, it constructed across two phase region. So first of all, the lever line is drawn in a two phase region at a constant temperature, so at a particular temperature, right. The second one, the intersections of the tie line and the phase boundaries on either side are noted. Now see here, this intersection of this tie line with the liquidus line represented as a concentration of liquid, and the tie line with the solidus line, it is represented as concentration of solid. So this tie line represent intersect two phases, one is liquid and one is solid, otherwise alpha and beta. So the first one is right, second one is also right. And the third one, perpendiculars are dropped from these intersections to the horizontal compositional axis, from which the compositions of each of the respective phases are read. Now see here, if I consider a compositional axis from the horizontal axis, if I draw a line, vertical line that intersect the lever line, so from this lever line, from this point and from this lever line, we will find different phases of an alloy. So the statement 3 also correct. So 1, 2, 3, all the 3 statements are related to lever line. So all the 3 statements are right. So the most appropriate answer for this question is D. Right. Now the next one, in which of the following micro constituents alpha ferrite and cementite phases are present? Right. 3 micro constituents were given: spheroidite, coarse perlite and fine perlite. Right. This spheroidite is a type of annealing process, spheroidized annealing process. So in this spheroidized annealing process, the resultant component, in the resultant component we will get a spherical form of cementite grains. This is cementite and this is alpha iron. Okay na? So we are converting the lamellar form of cementite into spherical form to increase the machinability here. And the second one is a coarse perlite. The perlite is also a mixture of alpha iron and cementite. In the coarse perlite, the grain structure is very large and the thickness, the distance between two cementite lines is more. So we can say it's a coarse perlite. This coarse perlite is produced from full annealing process, full annealing process. Full annealing process. Okay, so here it is cementite and this is alpha iron. And if we consider the fine perlite, this fine perlite is produced by cooling the material in air, that we call it as a normalizing process. So in the fine perlite, the cementite is present in the thin lamellar form surrounded by the alpha iron, but the thickness of both is very small. Here it is like that. So here I am considering it is a alpha iron, and here I am considering it is a it is a cementite. Now see here, this is a cementite. Okay, this is a cementite and this is alpha iron. So we can say from these three, all these three are having alpha iron and cementite. So the most appropriate answer for this question is D. 1, 2, 3. Right. Now the next question, which one of the following is the capacity of material to absorb energy when it is deformed elastically? You should remember this word, elastically, and then upon unloading to have this energy is recovered. Now that is nothing but a resilience. Now for example, this is a stress and strain. If I consider this is a stress strain curve, okay, it is an elastic limit. The area under the stress strain curve is nothing but resilience. Right, up to the elastic limit, once if you release the load, the material regains back to original state. So we can say the basic definition they asked from this question, so it is resilience, basic one. Right. Now the another question here, what is the shape of indenter for Vickers micro hardness testing technique? Right, it's nothing but Vickers hardness test. Vickers hardness test, okay, this Vickers hardness test is used to measure the hardness of very high hard materials. Very high hard materials, like you take examples, silicon carbide, tungsten carbide, cubic boron nitride. Okay, this type of materials hardness is measured by Vickers hardness test. For example, let us take silicon carbide hardness is some 2100 degrees Celsius. Sorry, not Celsius, it's a Vickers hardness number. And the CBN is approximately 7000 and diamond is 8000 Vickers hardness number. Such a high hard materials hardness is measured by Vickers test. Now imagine Such a high hard material hardness is measured by this test. Now think of it, what is the indenter tool material? The indenter tool material must be a diamond, and the shape of the diamond is pyramid shape. So the correct answer for this question is C. Right. Now the next one, the corrosion penetration rate is directly proportional to, it's a formula based one. Corrosion penetration rate is equal to K into W by rho A T. Right. So corrosion penetration rate CPR is directly proportional to weight loss. Okay na? The corrosion penetration rate is directly proportional to the weight loss. So, and it is inversely proportional to the density, inversely proportional to the area, inversely proportional to the exposed time, so that the most appropriate answer for this question is C. Right. Now the next one, which one of the following measures is correct to reduce the effect of galvanic corrosion? Now, generally to reduce the galvanic corrosion, the anode area must be larger than the cathode area. So here cathode area is larger than anode, so it is not correct. Then avoid an unfavorable anode to cathode surface area, this is correct. It uses anode area is small, anode area should be large, so this is not correct. It electrically insulates similar metals, it is not similar metal, it should be dissimilar metal, right? So the correct answer for this question is B. Right. Now the next one, consider the following statements regarding corrosion. Right. The first statement, the formation of film of atoms or molecules on the surface of anode so that corrosion slowed down is called as passivation. Right. Now if I consider local corrosion attached resulting from the formation of small anodes on a material surface is known as intergranular corrosion, it is not correct. Intergranular corrosion occurs at the granular at the grain bound region because of the more bond length, the external atoms easily bond with this metallic material and forms oxides, right? So this is not correct. Next one, preferential corrosion occurring at grain boundaries or at the regions adjacent to the grain boundaries is called as pitting corrosion. See, this definition is for this and this is for this. In a pitting corrosion, at a one particular point of material in depth, the corrosion takes place into the material. It's like a pit. Okay. So only at one point on the surface and moves into the depth from the surface. This is, we call it as a pitting. So 2 and 3 are not correct. So the most appropriate answer for this question is C. Right. Now, so these are the questions related to material science. Now there is one more question that is related to maintenance, right? Maintenance engineering. Now see the question. It's a very simple basic question. Consider the following statements regarding machine vibrations. Now the statement 1, if the mechanical stresses are below the acceptable safe working stress levels, the material involved, no direct protection is required. This is a simple direct statement, correct one. If the stresses exceed the safe level, corrective measures should be taken. Yes, there are different corrective measures are given like stiffening, reduction of inertia, bending moment, all these things. This is also correct. And third one, shock isolators differ from the vibration isolators. That is right. It's a different purpose and it's a different purpose. And especially that shock requires a stiffer spring and a higher natural frequency of the resonant element. So this is also correct. So for this question, 1, 2, 3, all 3 statements are correct. So the most appropriate answer for this question is D. Right. So these are the questions from the material science and maintenance engineering. Now our friend Devanand will continue with the heat transfer subject.
Hello everyone, my name is Devanand. I am a faculty of heat transfer in ESE Engineering Academy. So welcome to the solution series of ESE 2022. So from my subject heat transfer, there are 10 questions and which are very, very simple. I hope most of the students are able to do all that 10 questions. So let us move to the first question, which is a theoretical. Lump system analysis assume a distribution uniform temperature throughout the body, which will be the case only when thermal resistance of the body to the heat conduction. Lump body means where temperature is only function of time and lump body means where the resistance is 0. This is the common and direct case. That's why you need to go for option D. So no need to explain, it's a lump body, so resistance will be 0, so Biot number will be 0. So you need to opt option D. Next, which one of the following is not a fluid property? So please take care of that. In this case, the examiner focus on which is not a property for convection heat transfer coefficient. So as you know, convection heat transfer coefficient means Nusselt number, that is HL by K, which is a function of Nu and Re. Sorry. So which is a function of So which is a function of Reynolds number and Prandtl number. So Reynolds number include density, viscosity, characteristic length and velocity, where Prandtl number is dynamic viscosity, specific heat and thermal conductivity. So if you see, whenever you are going to calculate heat transfer coefficient, you require dynamic viscosity, which is a property, thermal conductivity also required, density also required. So in the question it is asked which is not a property. So in this case you need to go for rate of convection. Of course the rate of convection is not a property, remaining all are property, so you need to go for option. Next, what is the traditional expression for calculation of heat transfer in fully developed turbulent flow in a smooth tube that recommend Dittus-Boelter? This is the memory based question. If you know, you can easily find out. So if you know the Dittus-Boelter equation, so straight away you will go for option A, because Reynolds number raised to power 0.8 and Prandtl number raised to power n, and you know that n may be 0.3 or 0.4 depend on whether cooling or heating of fluid. That's why you need to go for option A. Next, the resistance wire of a 1200 watt hair dryer is 80 centimeter long. So given in centimeter and has a diameter of 0.3 centimeter. Okay. What is the rate of heat generation in the wire per unit volume? So as you know, heat generation Qg is equal to capital Qg by volume. Okay. So this is total heat generation 1200, volume is what? Pi. So pi by 4 d square L, or you can go for 1200 by pi r square L. Choice is yours. All the dimension you need to substitute and make sure that option is in centimeter. So no need to convert length and diameter. So if you do it, so you will get the answer 212 watt per centimeter cube. Hope you did the calculation. So just substitute, you will get the answer 212 watt per centimeter cube. Moving to the next question. In the first line only it is mentioned a 2 kilowatt resistance heater. So it's a resistance heater where the internal heat generation takes place, keep in mind, and given 2 kilowatt with a thermal conductivity 15, diameter 0.4, length 50 is used to boil the water by immersing in a water. Assuming the variation of the thermal conductivity of the wire with a temperature to be negligible, okay? And what is the differential equation to describe the variation of the temperature in the wire during steady operation? In case of steady state, there is no change in temperature with respect to time. So make sure that it's a wire, so it's a cylindrical coordinate system. So in cylindrical coordinate system, you know it's a memory based question. If you see 1 by r, d by dr, r dt by dr, and this is heat generation. Why? Because it is a heater. There is a internal heat generation, and right hand side storage is 0 because it's a steady state. Remaining options are, here r is not there, dimensionally it is not correct. Here it is 2r is there, and here heat generation is not there. That's why B, C, D easily you can eliminate. You can go for option A. Next, an electric current is passed through a wire 1 mm in diameter. Make sure that given in mm and 10 centimeter long. Okay. The wire is submerged in a liquid water at atmospheric pressure and the current is increased until the water boils. For this situation, H is given 5000 watt per meter square degree Celsius and water temperature will be 100 degrees Celsius. How much electric power must be supplied to the wire maintained at a wire surface temperature? So you know very well, in steady state, what you can say, if you want to maintain the temperature of the wire, whatever the heat is generated, that should be lost. Suppose if you want to maintain the temperature, whatever it is generating, that should go loss. So that is equal to loss due to convection, H surface area, Ts minus T infinity. Q is given. So see, in this case, so substitute all this value. So substitute all this value. H how much? It is 5000. Okay. So it is 5000. Then surface area, that is pi dl, and surface temperature, how much it is? 114 minus 100. Okay, 114 minus 100. So we need to find electric power. Simple thing, everything is given, 5000 given, diameter given, length given. You substitute in a proper unit. If you make it, so the calculation is so simple, everything will get cancelled out and you will get near to 22. Near to 22 watt you will get. Near to, if you round off. So based upon that, you can go to the option A. Straightforward, Q is equal to HA delta T. Substitute the value directly, everything, most of the thing will get cancelled out and you will get 22, and suitable option is 21.99. Next. In this case, a 2 kilowatt resistance heater wire, thermal conductivity 15 watt per meter degree Celsius, has a diameter 4 mm and length 0.5 meter, is used to boil the water. Okay. If the outer surface of the resistance wire is 105, what is the temperature at the center? So you know very well, center means maximum. So in case of cylinder, T max or T center, you can say minus Ts is equal to Qg R square by 4K. Qg R square by 4K, and this is per unit volume. So you can write Qg by pi R square L into R square by 4K. So see, R square get cancelled out, and remaining is pi, where you can substitute 22 by 7 and you substitute all the values. If you do it, so see, T max minus Ts already there, Ts is 105. So calculate this value and add it. If you do it, so you will get this one, 126 degrees Celsius. This will be the right answer. If you just calculate, you will get 126 is the right answer. Straight away, formula based question. Next, the thermal contact conductance. Make sure that in this case, it is conductance is given. The thermal contact conductance at the interface of a 1 centimeter thick aluminum plate is measured to be 11,000 watt per meter square degree Celsius. Okay. What is the thickness of aluminum plate whose thermal resistance is equal to the thermal resistance of the interface between the plate? So simple. I will tell you what is this. So these are the two plates are there. Having the thickness L, So this surface is not perfectly flat. So there is a contact resistance. But you know very well, in this question, it is given conductance, thermal conductance, which is nothing but the reciprocal of resistance. So what you can say, what is the condition, what is the thickness when the resistance offered by the aluminium is equal to resistance offered by the contact? So resistance offered by aluminium is equal to resistance offered by contact. But as you know, resistance and conductance are inversely proportional. So this is 1 by thermal conductance. So what you can write, so this is L by K, per unit area we are taking, 1 by conductance. Check the unit, 11,000 watt per meter square degree Celsius. So this is 11000. If you calculate the unit, it is meter square degree Celsius by watt. So both side unit will balance, and the thermal conductivity is already given. So thermal conductivity is 237. So this is something like 237 by 11,000. So easily it is, you can see it is 2 point something. So based upon that, this is 2.15 centimeter is the right answer. So this is your right answer, right? So this is the question. Next, in the design of fin, the error involved in one-dimensional field analysis is negligible. So this is the memory-based question. Remember one thing, the error is negligible when h delta by k less than 0.2. H delta by k less than 0.2, where delta is a characteristic length of the fin. Okay. So these are some questions from the heat transfer point of view. Now my colleague will take care.
Yeah, good evening friends. I'm happy to be here to present the machine design questions from the today's ESE paper. So overall, we have 11 questions from the machine design. So, really speaking, these 11 questions really pose a challenge to the students, because the conventional reading will not give you the answers as it is, because majority are not formula based. It is basically conceptual questions. But anyhow, let us try to look at the things about this particular one. The first question is related to wear rating of a long shoe drum brake is. So basically, in the wear rating, actually wear rating stands for, so their rate of wear in the brakes, clutches, and also bearings. So strictly speaking, the wear rate is proportional to what we call as, it is proportional to the pressure and the velocity. So here pressure here stands for the bearing pressure, which is load divided by area into velocity. But if you go with this particular one, so here we see the options here. So there is one area option also available in this particular one, but here wear rate is inversely proportional to the area, but it is said to be directly proportional, which is a wrong question. And remaining all related to what do you call it as friction power, friction torque, again friction power. So when you go with the friction power or friction torque and others, power is equal to 2 pi nt by 60, directly or indirectly. When you say torque is proportional, automatically power is also proportional. So if you go by that particular one, these three are almost same, but here it is inversely, it is also inversely, so these two statements is also wrong. So only one thing which is proportional to here is the frictional torque in case of this is mu into W into the areas or the dimensions. So when you go by this, so the wear rating which influences the mu, that is friction, so automatically we can say this is going to directly proportional to frictional power. So the option, the best suitable option for this particular question is the A, where it is directly proportional to friction power. The next question, if you go by this, what is the required basic dynamic load rating for a ball bearing to carry a radial load of 550 kg from a shaft rotating at 500 rpm? That is part of an assembly conveyor in a manufacturing plant. Take the design life as 1 into 10 to the power of 9 revolutions. So it is a straightforward question, numerical question based on the life of the ball bearings. So if you go by the life of the ball bearings, the straight away the question is C by P to the power of, if it is in this particular one, it is said clearly a ball bearing, it is to the power of K, K stands for 3 here, and whereas the life is given, the load on the bearing is given, only you are supposed to find the dynamic load rating capacity, that is C here, and the life is given as 1 into 10 to the power of 9 revolutions, whereas C is, I am supposed to find the load which is supposed to be here is 550 kg to the power of 3, and this is in million revolutions, means 10 to the power of 6 revolutions. And simply, if you calculate the C from this particular one, it found to be 5,500 kg, and that is the right answer, happens to be 5,500 kg here, which is a simple substitution formula and also a very basic formula. And in the machine design, one of the simplest question probably we can expect and most expected question, and even in our study material also, these type of questions are, many are available in our study material also. So if when you go for the next question, a catalog likes the basic dynamic load rating for a ball bearing to be 8,000 kg. So here the dynamic load rating means it is again C value is given, which is 8,000 kg. So this is the first one they have given, and he requires only a rated life of 1 into 10 to the power of 6 revolutions. So what is the expected life if it is subjected to a, so that means it is almost same question with the same formula which is being repeated. So life in this case is given, and even the dynamic load capacity is also given, and he is asking us to find what is the life of the bearing. So C is given, P is also given, so the dynamic capacity is 8,000 kg, load is 4,000 kg. Life you are supposed to find is, it is 8,000 divided by 4,000 to the power of 3. K is 3. It is in million revolutions, so 10 to the power of 6. So if you calculate this, simply you get it to be 2 cube. 2 cube means 8 into 10 to the power of 6 revolutions. So the life of the bearing will be a simple calculation. Now, fortunately, you got 2 questions based on the same formula with just a small variation in the data. This is the easiest question probably we can expect in this particular. Now, which of the following static load failure theories is used for ductile materials? Obviously, out of the 4 given, so maximum shear stress theory or the gas theory, which is generally used for ductile materials. It is a straightforward question. Next one is wear performance of the brakes can be improved too. So the options to increase the wear performance of the brakes. So here we have 4 options. Let us try to examine what are the 4 options we have. First one is keep the pressure between the friction material and the material of the disc or drum as high as practical. So if you try to see the generally the wear rating or the frictional torque, so which says that, so which is mu into W into the R for normally this particular one. So when you try to take this, if you see the more torque to be transmitted, either you have to increase mu or to increase W or to increase the dimensions. So if you go by this, the first option is if you can increase the pressure, that is the bearing pressure on this. If I want to increase the bearing pressure, so bearing pressure is nothing but the allowable bearing pressure multiplied by the area. So if you want to increase the load on the brakes or the clutches, so you need to increase the pressure. So this is the first option is correct. Let us try to examine the remaining options also. Specify friction material that have low bonding strength. So low bonding strength, it only indicates that if you have a low bonding strength with the constituent particles, it easily slips away. This is not the correct answer. So the next one is, so specify friction material that have relatively high addition, but high addition strength or low addition strength. So basically, these are related to only the bonding, which is not related to the torque transmission one. Provide high hardness on the surface of the disc. But if you increase the hardness, automatically it increases the mu value. As we said, you can increase the mu, but however, whatever the hardness you can increase, but mu cannot be increased beyond certain value. It is maximum 0.5 you can increase. But if you increase the W, so W can be increased by increasing the bearing pressure. So out of these 2 options, this is also one option, but this option has a limitation. So obviously, this is going to be the most suitable one, and this is not the most suitable one. This is also one of the right answers, but it has a limitation. So obviously, we will go with the option A for this particular one. So this is again on the brakes. Now, the next question is, consider the following statements regarding the parameters involved in the rating of clutches and brakes. So when you go by this, it is also related to frictional torque. So how much torque the brake or clutch can hold. This depends on acceleration, because the torque required generally is equal to I into alpha. If you require more acceleration, automatically you require more torque capacity for the brakes. So automatically, if you have more acceleration, this influences the torque, so automatically rating also involved. So this is also the right answer. And the next one is time required to accomplish the speed change. And automatically, when you require the time, alpha is nothing but, again, V1 minus V2 by A, when you go by initial minus final velocity by the time. So automatically, time also requires in the, and this is also right answer. Next one is the cycling rate is required, but this is cycling is related to actually the fatigue. So when you go by this, so fatigue is not related to the ratings. So obviously the right answer will be the first and second options, that is 1 and 2 are the correct options. So obviously, we go with the B option for this particular question. And next one is, in the design of spur gear, the load distribution factor can be minimized by specifying which of the following. So obviously, we are coming across generally in the gear design, we will be coming across Lewis form factor or other velocity factor and others, but it is not those two factors, but it is related to load distribution factor. That means how well the load can be distributed on this particular one is. So relatively, this is related to what do you call it as face width. When the face width is narrow, okay, so the distribution is uniform to be considered. So obviously, one is narrow face width, and the next one is long shaft spans between the bearing. So this is really, it is not included in our regular study, but it says that between two supports, when you go with between two supports, so let me say I have two supports in which the bearing or the gear is supported. So when you go and consider this particular gear between the two supports, where this gear is actually located is going to make a difference in the load distribution. And this is actually considered from center or mid-span. So this mid-span to this distance, if it is increasing, then the distribution is said to be not uniform. So if it is at the center, it is considered as the uniformly distributed. But however, this is, let me say this is one distance and this is L is the total span. So this S by L is going to make a difference in this particular one. So if you keep this distance and you go on increasing the length of the beam or length of the shaft, automatically distribution will be good. And as per this, this is also actually long shaft span will lead to what do you call it as more distribution of the or uniform distribution of the load. But when you go with the teeth, so when you go with accurate teeth and others, so it is teeth actually related to error in the teeth profiles. When you say accurate teeth, so it definitely reduces the losses. So if it is more and more accurate, the errors will be less and less. So definitely when error is less, dynamic load will be less. So automatically this also increases this particular one, but actually this is also correct. And if you go by this, 1, 2 and 3, we can say is the correct answer. It is not the teeth number, but it is actually the accuracy of the teeth profile. So when you go with accuracy of teeth profiles, definitely more accurate, it is less error and less dynamic load. When you have less dynamic load, automatically the load distribution will be more. That is why all three factors will definitely, in the design of spur gears, the load distribution factor can be minimized if you maintain this particular one. Next one is, which one of the following failure criteria is used in graphical method equation? So here, actually, if you see this, all four options given, these are all first, second, and the last option, A, B, and D, we regularly use in the design of fatigue failure. But however, you are coming across another one called Smith. You are coming across Smith diagram fatigue failure criteria. This is also, which is generally new for regular course, but this is also similar in line with Soderbergh criteria. But however, the default theory of failure, fatigue failure theory, we generally use is Soderbergh fatigue failure criteria for all the ductile materials. Mostly we use only ductile materials. So the default theory we use is Soderbergh failure criteria. So option is A, even though it looks like Smith diagram, probably people tend to go with that it is a graphical based one. But however, Smith diagram is also similar to these three, but in a different version. It is trying to predict the failure theory. But for ductile materials, we generally, the default criteria is Soderbergh criteria. And the next one is, which of the one of the following is used in case in which the clutch runs free when the machine is being driven in the intended direction. So when you say intended direction, in the regular direction, that means direction will not be changed. It continues to rotate in the same direction, but it is supposed to run when it is free. That means even though there is a shift in the power from one machinery source to the another machinery source, still it has to run even during the failures and others. So this will be the correct option is overrunning. In case of overrunning, so even though it is shifted from one source to the other source, still it continues to rotate in the same direction. But however, in backstopping, it do not change the direction, but it continues to, it will not reverse the direction, but it will stop. So underrunning and front stopping will not be the right options. The right options happens to be the overrunning. Now, in a band brake, the tension in the band decreases from the value P1 at the pivot side of the band to P2 at the lever side. If R is the radius of the drum, then the net torque on the drum is. So when you take a drum, so these are the two tensions on the both sides. One is P1 and another one is P2. Whatever may be the sides, generally the torque happens to be P1 minus P2 is the net into R. So the right option happens to be P1 minus P2 into R will be the very simple question. The torque on the drum will be band brake due to this is P1 minus P2R. So next one is 138. Consider the following statements. Regarding the transmission shaft, so we have counter shaft is secondary shaft which is driven by the main shaft from which the power is supplied to a machine component. So counter shaft is always connects between the main power unit and to the next one. So obviously this statement is correct statement. Second one is jog shaft is an intermediate shaft. This is also an intermediate shaft between the two shafts. So this is also a right option. Third one is a line shaft consists of a number of shafts which are connected in an axial direction by means of couplings. This is also a right option. So out of the three different shafts mentioned here, one is counter shaft, another one is jog shaft, another one is line shaft, and the statements given for all the three are correct. So right option here is 1, 2, and 3. Okay.
Next comment IM and VAR. So we have only 3 questions. So the first question is, in PET, which one of the following estimates, which one of the following is the estimator expect that he may come across some sort of uncertainties and many a time the things will go right. So when you see this particular thing, optimistic time, so where the conditions are most favorable and everything is moving in the right direction. And most likely time possibility is there, but luckily most likely time is not given. So optimistic is the shortest possible time where the things are moving in the right direction. So straight away we can take option B, optimistic time. Next question. In which of the following the criticality of the item is most important than the cost factor of the item? As you know, the option ABC analysis. ABC classification is based on annual consumption value, annual usage value, where annual usage value is equal to unit cost into annual consumption. But here it is mentioned criticality. And coming to the second one, VED analysis. So vital, essential and desirable, where the basis is criticality of usage. So vital elements are very important, which will cause the main problem, the entire plant, and the essential, desirable, as you know, it's the criticality of usage. P system, Q system, straight away we can remove this. So ABC classification is based on annual usage value. So what is the right answer? VED. So straightforward, very simple question. Next, total quality management. As you know that you come across so many quality gurus. So Deming, Taguchi, Juran, so famous in TQM. But Skinner is actually psychologist and philosopher, is only related to psychology, is no way concerned to total quality management, just odd man out. Okay, so that's all about IM and VAR. We have only 3 questions. So next, Veerakumar sir is going to continue.
Okay, friends, welcome to ESE paper presentation. Here we will be discussing about the questions concerning the IC engines. Only 3 questions were given. 2 are theoretical questions and 1 is a problematic question. So the question is, which one of the following statements is not correct? A simple and convenient apparatus used for the volumetric analysis of dry flue gases is known as ORSOT apparatus. The calorific values of liquid fuels are generally determined by using an ORSOT apparatus. The calorific values of solid and liquid fuels are generally determined by using a bomb calorimeter. In ORSOT's apparatus, potassium hydroxide is used to absorbent to absorb carbon dioxide. These are the alternatives given. Here the important question is, which is not correct? Not correct. So here if you see, the calorific value of liquid fuels are generally determined by using an ORSOT's apparatus. Calorific value is determined by using bomb calorimeter, not by ORSOT's apparatus. ORSOT's apparatus is used for determining the composition of dry flue gases. Therefore, the option is B. Option is B. Next. Here, the next question is, what is the amount of air required to burn 1 kg of fuel and products of combustion for a fuel percentage composition which is given as carbon 70%, hydrogen 30%. This is a numerical question. Here, carbon percentage is 70%, hydrogen percentage is 30%. So we should know the formula first. Okay. The formula is air fuel ratio. Yes. Here we are determining the air fuel ratio for a particular fuel. The particular fuel is having carbon 70% and hydrogen 30%. So the formula for determining the air fuel ratio is given by air fuel ratio is equal to 100 by 23 into 8 by 3C plus 8H2. Here only two components are given, carbon and hydrogen. Hence, we have written the formula only for carbon and hydrogen, but nothing else. Now this is 100 by 23 into 8 by 3 into 0.7 plus 8 into 0.3. So this will come to 100 by 23 into 5.6 by 3 plus 2.4. Now, this is equal to 100 by 23 into 5.6 by 3 is how much? It's roughly 1.87 plus 2.4. So this is 100 by 23. 2.4 plus 1.8 is 4.2. It is 4.27. Okay. Or this is 427 by 23. 427 by 23 can be written as 460 by 23 minus 33 by 23. What is 460 by 23? 20. What is 30 by 23? Minus 1 point, roughly 10 by 23 works out to 0.4 or something, roughly. So 20 minus 1.4 is how much? 20 minus 1, 19. Roughly the answer will be around 18.6. The closest answer to 18.6 is given as 18.54. Hence the answer is 18.54. This is another question given on fuels. It deals with to find out which is the correct statement. First one is ultimate analysis. Ultimate analysis generally deals with the elemental composition of the fuel. But here, in the description, they have not given that, but they asked about fixed carbon, volatile matter, moisture and ash. Actually, this is for proximate analysis. So, ultimate analysis and proximate analysis are interchanged. Hence, this is wrong and this is wrong. Both are wrong. The calorific value of a solid or liquid fuel is defined as the heat evolved by the complete combustion of unit mass of fuel. So, calorific value of solid and liquid fuels is nothing but the heat evolved by the complete combustion of a unit mass of fuel. Hence, the right statement is C.
Let us see this problem. The work required for compressing 1 kg of air is minimum if the process of compression is carried out. Work required is given in the problem, and for compression process, and we need minimum work input. For compression process, as we know, work is given to the system, therefore work input. So these are the various processes given: ABCD, adiabatic process, isothermal process, isentropic, and isochoric process. As we know that on PV diagram, area is work transfer. Let us draw the PV diagram. So these are the various processes given. This is PV diagram, pressure volume diagram. This is constant volume process. And from thermodynamics point of view, we know slope of adiabatic is more. This is PV power gamma is equal to constant. And this is PV is equal to constant. We know slope of adiabatic is more compared to isothermal. And generally, in thermodynamics point of view, polytropic is in between isothermal and adiabatic. This is going to be polytropic. PV power N is equal to constant. And compression process is given and work required, minimum work required. As we can see from this graph, the minimum area is going to be for isothermal process. If we take the area, the minimum area is going to be for isothermal. This is the minimum area or least area for the given processes. For isothermal, area is minimum, therefore the work transfer is minimum. So for compression process, minimum area is for isothermal, therefore for this problem, answer is going to be option B. Adiabatic process is given, and theoretically, adiabatic process, isentropic process, both are same, A and C, and B is isothermal, D is isochoric process. And for isochoric process, the area is going to be maximum. Therefore, for this problem, minimum work required is isothermal process. Let's go for next problem. Which one of the following is the intensive thermodynamics property? Intensive property is given, and we know already pressure is intensive property. Enthalpy means it is total enthalpy. Total enthalpy means it is extensive property. Internal energy means it is total internal energy, that is also extensive property. Entropy means simply entropy, internal energy, enthalpy means these are extensive properties, and pressure is intensive property. Therefore, for this problem, answer is option A. Let's go for next problem. This is statement problem, statement 1 and statement 2 given. Statement 1, heat and work are boundary phenomenon and recognized only when they cross the boundary of the system. And we know very well, heat transfer is observed at the boundaries and work transfer also observed at the boundaries. As the work is crossing the boundary, it is work transfer, and as the heat is transferring, heat transfer also boundary phenomena. So heat and work boundary phenomena, it is a straight point. We know very well, heat and work, they are boundary phenomena. Statement 1 is correct. And statement 2, heat and work depend on path followed by the system during a process. Yes, it is also straight point. Already we know work transfer is a path function and heat transfer also a path function. So therefore, heat and work both are path functions. Yes, it is also straightforward statement, which is correct. Statement 2 is correct. But statement 2 is not supporting statement 1. Individually, both are correct. Statement 1 and statement 2, individually they are correct.
but statement 2 is not supporting statement 1. Therefore, for this problem, answer is going to be option B. Let's go for next problem. And it is a numerical based question. A gas weighs 16 Newton per meter cube. It is a specific weight is given. We know specific weight, rho g. And specific weight is given 16 Newton per meter cube. And temperature is 25 degrees centigrade is given. Absolute pressure, it is 0.25 Newton per mm square is given. What is the gas constant? For this question, we need to calculate R, gas constant R. And if you check the options, Newton meter is joule, joule per kg Kelvin. We need to calculate gas constant, characteristic gas constant. Simply gas constant means it is a characteristic gas constant. So it is R. We need to calculate in joule per kg Kelvin. Temperature is given 25, pressure is given, and acceleration due to gravity is given 9.81 meter per second square. Let's solve this problem. Specific weight is given. As we know, specific weight can be written as rho g. Rho can be written as specific weight divided by acceleration due to gravity. And for a gas simply gas is nothing but it is ideal gas only. If nothing is mentioned, gas is ideal gas. For ideal gas, we can write P is equal to rho RT. Ideal gas, P is equal to rho RT. Rho can be written as specific weight by G. P is equal to rho can be written as specific weight divided by G into RT. So this is the final equation. From this equation, R can be calculated like this. R is equal to P into G divided by specific weight into temperature. Pressure is given 0.25 Newton per mm square. This can be converted. If you convert 0.25 Newton per mm square, it is going to be 250 kilo Newton per meter square. I repeat, pressure is given 0.25 Newton per mm square. This can be written as 250 kilopascals. It is 250 kilopascals into acceleration due to gravity, which is already given in the problem, 9.81, by specific weight is already given. Specific weight is already given 16 Newton per meter cube. It is 16 into temperature is 25 degrees centigrade. Temperature 25 degrees centigrade is given. 25 plus 273, it is going to be 298. 25 plus 273, it is 298 Kelvin. Therefore, we can simplify like this. So 9.81 roughly it can be assumed as 10. Let us say 250 into 10 divided by 16 into, it is 298. Let us say roughly 298 is, let us say roughly it is 300. So from this equation, we can write from this equation 250 into 10, it can be written as 2500 by 16 into 300. 16 into 300, roughly it is 16 into 300, it can be written as 4800. So from this equation, we can cancel zeros. Therefore, 25 by 48. 25 by 48, it is a simple calculation. Let us say 48, let us assume 48 is 50. So 25 by 50, roughly it is 0.5. Roughly it is 0.5. But since it is a less value, to 48 it is a less value, so roughly it is going to be 0.51 something. Since pressure is taken as kilopascal, we have taken pressure kilopascal, therefore it is going to be kilojoule per kg Kelvin. Characteristic gas constant, it is going to be kilojoule per kg Kelvin. Now let us check the options. It is roughly 0.51 something. Let us check the options. And it is kilojoule per kg Kelvin. If you multiply with 1000, if you multiply it will be 500 something. Let us say it is 514. Roughly it is 514 joule per kg Kelvin. 514 joule per kg Kelvin. Let us check the options. It is 514 point something, 542, 562, 592. So just now we have seen it is 514. Therefore, for this problem, answer is going to be option A. So this that's all about the thermodynamics. Next, our friend Mr. Madhushekar is going to take next session.
Right. I missed 3 more questions related to material science. Previously I discussed 12 questions. Now I am going to discuss these 3 more questions. Now in this question, for 99.658% of iron and 0.358% of carbon alloy at a temperature just below eutectoid, the fraction of pro-eutectoid ferrite and perlite, right? So for this case, you have to draw a lever line from the iron cementite phase diagram, okay? You have to draw a lever line from the iron cementite phase diagram. Actually, in this question, it is given the temperature that is just below the eutectoid temperature. So just below the eutectoid temperature, consider a lever line, and at 0.35% of carbon, just assume C0 is equal to 0.35% of carbon. And what they are asking micro constituent, that is pro-eutectoid ferrite and perlite, right? So the pro-eutectoid ferrite and perlite is present in this region. So this is the lever line actually. So if you consider the lever line, this is C0 that is equal to 0.35% of carbon. This is C alpha that is 0.025% of carbon, and this is C perlite that is 0.8% of carbon approximately I am taking. In this question it is given just below eutectoid temperature, that's why I am considering here. In case if temperature is not given, we should take the temperature that is at room temperature, right? So now if I consider mass fraction of pro-eutectoid alpha, pro-eutectoid ferrite, that is equal to C perlite minus C0 by C perlite minus C alpha, this side. So that is 0.8 minus 0.35 by 0.8 minus 0.025. By solving this, you will get approximately 0.58. And mass fraction of perlite, that is equal to 1 minus mass fraction of pro-eutectoid alpha. Pro-eutectoid alpha, that is approximately you can take 0.42. But in this question, the options are not there here, these questions. But in case if we consider at room temperature, you will get 0.56 instead of 58. Then 0.44 you will get instead of 0.42. So these options are not related to at accurate, like you take the most appropriate answer, this is the answer, but this answer is related to at room temperature. In case at eutectoid temperature, this is 0.58 and 0.44, but we should take the most weightage answer. So I am taking answer B is the correct answer for this question, right? Next, another very simple theoretical type question. Consider the following statements regarding the mechanical behavior of iron carbon alloy. Now, the first one, martensitic steels are more ductile. It is absolutely wrong. Martensitic material is a brittle in nature. It is produced by fast cooling of the material by quenching in water. Second, tempered martensite is relatively brittle. Martensite is brittle, but after tempering process, it is relatively ductile, somewhat ductile. So it is not correct. The fine perlite is more brittle than coarse perlite. It is right. Fine perlite is more brittle because of more grain boundaries compared to coarse perlite. So only 3 option is correct. So answer for this question is 3, D, C. Right. Now the last question, which of the following contain other alloying elements such as copper, vanadium, nickel and molybdenum in combined concentrators as high as 10 weight%? Generally, if the alloy content is less than 10%, we call it as a low alloy steel. If the alloy content is more than 10%, it's a high alloy steel. So it is a low alloy steel first of all. And within the low alloy steel, there are so many alloying elements we are adding to improve the properties of the material. Copper, vanadium, tungsten, nickel, like that. So this type of alloy is high strength low alloy steel. Because of adding this many alloying elements, it gives you very high strength and high toughness. So, but total alloy content is less than 10%. That's why it's a high strength low alloy steel. It is used, especially it is used to make signal towers, cell phone towers like that, etc. So the most appropriate answer for this question is D. Right. So the next our colleague Prakash Chandra Singh will take engineering mechanics.
Hello dear friends, this is me Prakash Chandra Singh, and here we are going to take a detailed solution over engineering mechanics. So first of all, this is your question number 73. Please read this question statement first. So for moderate speed, this question is based over the friction. And earlier I was taught in your live session, the concept behind the question is very important, and in the live session, I already told this concept, okay? So for moderate speed, the force of friction, here examiner asked about the force of the friction remain nearly constant and decrease slightly with increase of speed. So what is the relation between the friction force and the load? If you are going to draw a diagram, so you can take like this. This is your what? Friction force and load relation. And if you are going to consider a body and apply some load P, so the friction force is suppose like this. So the relation between the friction force and load is what? Like this. Firstly linear and after that constant. But if you are going to consider with respect to the speed, so under the moderate speed, under this what? Moderate speed, this value is remains constant. This is your what? Under moderate speed. Okay, moderate speed, right? And here increase with speed, and when at, that means at high speed, when you operate under the high speed, so here in this case your value is gonna be slightly decrease. So for this question, the statement first is 100% correct, my dear friends. 100% correct. Okay. Now, what about the statement second? Here, in this statement second, the friction is dependent on, no, friction is your this friction is independent on extent of area, right? On extent of area, and but here independent on normal reaction. No, my dear friend, this is your what? This is your what? Normal reaction. So for this case, your friction is dependent on normal reaction. So this statement is totally wrong. So for this question, your correct option is your what? C option. Very easy question, my dear friends, right? Now next question is your what? 81. This question is very interesting, my dear friends. Very interesting and very beautiful question, right? Here examiner asked about the velocity ratio and asked about what? Efficiency. What is the value of efficiency? First, the question is what? The initial frictional resistance of an unloaded pulley block is 2.6. Okay, initial friction is your what? 2.6 kilonewton, right? And the friction increase at the rate of 1.4 kilonewton per 100 kilonewton load, and that means additional friction is your what? 1.4 per 100 into at every loaded diagram is like this. Okay, and the velocity ratio is given as what? 18. The efficiency of the block at the load 1200 kilonewton is approximately. That means what? What the formula of efficiency with respect to the mechanical advantage and velocity ratio is this. Okay. So in this question, velocity ratio is given as what? 18. So what about the mechanical advantage? Your mechanical advantage is nothing but your what? This load divided by what? Effort. So here, now you are going to consider a diagram. This is a very beautiful question over the mechanics, right? In this question, first of all, you have to take sub-pulley mass system like this, right? And from here, we are going to understand the meaning of velocity ratio, right? Like this. And this is your what? Weight of what? 1200 kilonewton. So if you are going to pull this wire, so this is your what? Effort. And here we are interested to find this effort value. What is the value of this effort, right? So here I want to slide this Okay, okay, right. Okay, the value of effort is nothing but your what? What? This is your load, right? Load upon velocity ratio plus some additional frictional resistance, this and this, right? So you need to add this value 2.6 plus 1.4 divided by 100 into what? 1200. So from here you need to calculate, because this value is your what? 18. Right? So here you can get your approximate value is approx 86. Approximate. You can get a value, approximate value is your what? 86. Here 1.4 into 12, something around 16, and here 2.6 is what? 18.6 plus 1200 divided by 18. So here you can get an approximate value of what? 86, right? So you can put this 86 value over here. So from here you can easily get the value is what? Approximate 14. What? 1200 divided by 86. So you can get 14, your mechanical advantage. Now 14 divided by what? This value is 18. 14 divided by 18 into 100. And this will be your answer is what? Approximate 77%. You can easily calculate this question. First of all, you need to calculate the effort value. And the effort value is nothing but your what? Load by velocity ratio plus extra frictional resistance, which is also provided by the U. So the effort value is nothing but your what? 86. Approximate value is what? 86. And you are going to put this 86 value over here, and from here you can get 14, and you need to put this 14 value, 14 divided by 18 into 100 is what? 77%. Right? This question is very interesting question, my dear friends. So for this question, your correct option is what? B option. Right? Please note it down. Okay? Now, next question is your what? A body of weight 100 Newton. A body of weight 100 Newton is placed on a rough horizontal plane. If a horizontal force of 60 Newton is just cause the body to be slide. It's a very beautiful question over the friction, right? So then the coefficient of friction. In this question, you need to find this static coefficient of friction, right? So what will be the formula? First of all, you need to draw your case. Your case is look like this. The weight of the body is nothing but your what? 100 Newton. 100 Newton. So it will just equal to the normal reaction. N is equal to, W is equal to what? 100 Newton. Okay. Now next, a horizontal force is act here is amount of what? 60 Newton, right? So a frictional resistance gonna be introduced in this direction. So this P is equal to what? This static friction, right? And this value is nothing but your what? 60 Newton. And what is the formula of friction? Force, static friction force is nothing but your what? Mu s into N, right? So in this question, you need to find this mu s value. What is the mu s value? The Fs value is nothing but your what? 60, and here divide by N, that means 100. And from here you can get easily your answer. This is your what? A option is correct for this question, right? Please note it down. Very beautiful question over the friction, right? Now next question, and this will be your last question over engineering mechanics. Okay, which one of the following principle state that the inertia force and couples and external force and the torque on a body together give statical equilibrium. So my dear friends, in live session also I told you where inertia force gonna be introduced, you go with what? D'Alembert principle, right? So in this question, you need to observe your what? Inertia force is given. That means what? Your D'Alembert option is correct. So my dear friends, here this session is going to be finished, and Vahis sir, my friend Vahis sir, is coming to introduce for theory of machine solution.
Welcome students, I Mohammad Wahidullah will be discussing theory of machines from the ESE paper. So this will be our first question. Which of the following is the angle through which the cam turns during the time the follower rises? So this is a commonly known definition to everyone. That is, the angle turned by the cam when the follower rises is the angle of ascent, or ascent is the keyword. Directly we can see, or directly just by choosing the keyword, we can say that option A is correct. Okay, and angle of dwell, for the angle of dwell, we'll see that the follower is going to descend down. Okay, sorry, angle of dwell, the follower remain, there is no motion for the follower. Follower will not have any motion. Okay, follower will not have any motion. Okay, and angle of descent, you know that follower is going to move in the downward direction, or it is going to descend down. And angle of action is basically the combination of angle of ascent and angle of descent. Angle of ascent is the initiation of the follower arising. Okay, and angle of descent is where, or the basically angle of descent is where the follower is going to move downwards, and angle of action will be initiation of angle of ascent and termination of angle of descent. Okay, so this will be angle of ascent plus angle of descent. This will be angle of ascent and angle of descent. Okay, so the correct option will be option A. Right. Moving forward to the next question. Yes. Consider the following statements regarding cams. Statement 1 says that base circle is a smallest circle tangent to cam profile contour drawn from the center of rotation of the radial cam. Yes, base circle is the tangential to the cam profile, and we know this very well. Next is pitch curve is the curve drawn by the trace point, assuming that the cam is fixed and the trace point of the follower rotates around the cam. Okay, these two are the direct statements given for the trace point and the base circle. The third statement is that pitch circle is the circle passing through the pitch point and concentric with the base circle. So for statement 3, there are two versions available. Actually, you have pitch circle is the circle passing through the pitch point, which is given, and other than that, in some books you will find this to be referred as prime circle. Prime circle. Okay, this to be referred as prime circle. So statement 3 is also correct. Okay, and the fourth statement, the smallest circle drawn tangent to the pitch curve is also known as prime circle. Even the statement 4 is also correct. So here if we debate that the statement 3 cannot be correct, so by choosing the options, we will be not able to find here 1, 2 and 4 combination. We will not be able to find here 1, 2 and 4 combination. 1, 2, 3 and 4, all this is given. So option D will be correct answer. Option D will be correct answer. Okay, next question guys. Yes, this question is slightly out of the way, and yeah, it is relating to acceleration analysis. Yeah, here is the question. Consider the following statements regarding the acceleration analysis. Okay, statement 1 says that graphical method to find the location of the center of curvature of the locus of point on the moving body is known as. Here this statement or this method is used for actually not for Bobelier construction, it is for Hartmann construction. It is for Hartmann construction. Okay. Next is statement 2, a graphical method by which the inflection circle can be drawn without requiring the curvature of the centroids. It is centroids guys, it is centroids, is known as, this will be called as Bob-Hillier construction, okay. Bob-Hillier construction. So here the statement 1 is false and statement 2 is false. Next is the third statement. Bob-Hillier theorem states that the angle subtended by one of the rays with the curvature with the centroid tangent is equal to negative of the angle subtended by the other ray with the collineation axis. This statement is correct. This statement is correct. Okay. So here the correct option will be, that is option B. Option B will be the answer. Moving to the next question. Yes, this is a very straightforward question from the Grashoff's law. Consider the following parameters. S represents the shortest link, L represents the longest link, P and Q are the intermediate links. Okay. So as per the Grashoff's law, for there to have the continuous transmission of relative motion, minimum one link should be undergoing full circular motion. Okay. So but here it says that it is S plus L greater than P plus Q, which means that none of the links will be undergoing full circular motion. Okay. So it will be a triple rocker. It will be a triple rocker. Okay. We call it as rocker, but triple rocker, it is not a triple point, it is a triple rocker mechanism, or we call this as rocker also. But you might think here that rocker mechanism means it will be input will be rocker and output will be rocker. What about the coupler link? So here triple rocker will be giving you the precise information. Okay. Moving forward with the next question. Yes. A uniform disc of 150 mm diameter has a mass of 5 kg. It is mounted centrally in the bearings which maintain its axle in the horizontal plane. Okay. So some shaft is given to you and it is supported by the bearings and some disc is mounted on that shaft. Okay. The disc spins about its axle in the horizontal plane. The disc spin about it is spinning with a speed of 1000 rpm. It is spinning with a speed of 1000 rpm. This will be axis of spin. Next is, while the axis precises uniformly about the vertical at 60 rpm. About this vertical, this is going to precise, okay, or it is going to turn. The gyroscopic couple on the disc is approximately dash. This is a straightforward single formula question, guys. So here gyroscopic couple is given by, that is C is equal to I times of omega into omega p. Okay. So I here will be, it is a uniform disc, so I will be assuming this to be a cylindrical disc. So moment of inertia will be given by mr square by 2. Mr square by 2 will be the moment of inertia formula, guys. Okay. So this will be mr square by 2 times of omega into omega p. So this m will be how much? It is 5 kg. It is 5 kg and the diameter is 150, so radius will be 75. 75, if I convert this into meters, this will be 10 power minus 3 whole square divided by 2 into omega will be 2 pi into 1000 by 60. 2 pi into 1000 by 60. And this will be about the vertical axis. Yes, velocity of precision will be 60. Okay, velocity of precision will be 60. So upon calculation, we'll be getting this answer as 9.2 Newton meters. 9.2 Newton meters. This will be the answer. That is option D. Option D will be the answer. Okay, this was one question from the gyroscopic couple. Next question, guys. Yes, this is also a very fundamental point in the balancing of masses, which will be distinguishing between the static balancing and the dynamic balancing. Okay, yes. System of rotating masses is in dynamic balance when there does not exist any resultant centrifugal force only. So if I say option A, then it will be static balancing, guys. Static balancing. okay, that is sigma f equal to 0, there does not exist, yes. There does not exist any resultant couple, which means that sigma m is equal to 0, which means it is sigma m is equal to 0. Option C says that there does not exist any resultant centrifugal force as well as resultant couple also. If sigma f is equal to 0 and sigma m is also equal to 0, then the system is said to be dynamically balanced. Then the system is said to be dynamically balanced. Okay. If there exists both resultant couple, okay, if resultant force is also existing and resultant couple is also existing, then the system will be unbalanced. As per option D, it will be unbalanced. Okay. So here the correct option will be option C. Option C will be correct answer. Okay. Moving to the next question. Yes. In the shaft, rigidity and dynamic consideration, shorter shaft lengths. Okay. Option A says that increase deflection and reduce the critical speed. Okay. Here critical speed basically represents the, you can also call this as natural frequency also. Okay. You can call this as also natural frequency. Okay. Option A says that increase in deflection and reduction in critical speed. So here omega, that is omega n, is equal to root over k by m. Root over k by m it is. Root over k by m. So here the stiffness of the shaft, or stiffness, here shaft will be analyzed like a beam. So here stiffness of the shaft k will be given by EI times of EI by L cube into some constant. That constant can be any number, so depending on what type of beam we are selecting. So here from this equation I can say that k is inversely proportional to L cube. K is inversely proportional to L cube, and omega n is directly proportional to root over k, and k is proportional to, or k root over k is inversely proportional to L cube also. Okay. So here we can say, for if the length is decreasing, if L is decreasing, okay, omega will be increasing, omega n will be increasing, okay, omega n will be increasing, and deflection is given by WL cube or WL power 4 by EI into some constant, okay. So what type of beam, that constant will be decided on what type of beam we are selecting. So here delta is directly proportional to length. So with the reduction in length, there will be reduction in deflection also. There will be reduction in deflection. So L, when we are decreasing, delta also decreases, omega n increases. So now we are required to choose which is the correct option. So here, yes, with the reduction in length, the deflection will be decreasing. The deflection will be decreasing, and reduction in critical speed. This is wrong statement. Next is, with the reduction in length, deflections will be decreasing and the critical speed or the natural frequency will be increasing. So option C is wrong. Option D will be correct answer. Option D will be correct answer. Right. Next question. Yes. A cantilever beam of negligible mass has a mass m at its free end. Okay. This is a cantilever beam having a mass at the free end, length L. If the length of the cantilever beam is halved, okay, if you are reducing this length to L by 2, okay, so what is the factor by which natural frequency is increased? So we have written, we know the formula of this cantilever beam. The stiffness of cantilever beam is given by, that is 3EI by L cube. Okay, 3EI by L cube. So now the stiffness by m will be the expression for natural frequency. This will be 3EI by L cube. This will be the natural frequency expression before the length is halved. Before the length is halved. Now if length is reduced, if the length is halved, what happens is 3EI by m times of this will be L by 2 whole cube, L by 2 whole cube. So this modified natural frequency will be increased by root 8 times of omega, or the factor will be root 8 times. That is option A will be the answer. Option A will be the answer. Okay, next question. Yes. This is another question from the mechanisms chapter. Consider the following statements regarding the kinematic pairs. Statement 1 is the pair has a point or line contact between the links. It is known as lower pair. Okay, if there is point and line contact, it will be regarded as higher pair. So statement 1 is wrong. Statement 1 is wrong. Okay. Next is when the elements of a pair are held together mechanically, it is known as closed pair. Yes, this is a correct statement. Okay. Next, statement 3, if two meeting links have a turning, okay, turning as well as sliding motion, turning as well as, this is as well as, okay, as well as sliding motion between them, they form a screw pair, or basically we call it as helical pair also, where the rotating motion, okay, or I can say the sliding motion is a function of theta, is a function of angular motion. Okay, so that happens in the helical pair. Statement 3 is also correct. Statement 3 is also correct. Next, when the two links of a pair are in contact due to the force or gravity, they constitute an unclosed pair. Yes, if they are brought in contact by the application of force or by the gravity, they will be forming an unclosed pair, or we will also call this as force closed pair. With the help of force only we are able to close the pair. Okay, we call it as force closed pair also. Okay, so this is also correct answer, that is statement 4. So here we are required to choose, that is statement 1 is false, 2, 3 and 4 are correct. So 2, 3 and 4 are correct means it is option D. Option D will be the answer. Okay, next. Yes, this is another question from the gyroscopic couple. Another question from the gyroscopic couple. Yeah, the turbine rotor of the ship has a mass of 3,500 kgs. Mass is 3,500 kgs. Okay, and the radius of gyration is 0.45. K is equal to 0.45 meters, and the speed of 3,000 rpm. And a speed of 3,000 rpm. N is equal to 3,000 rpm. Okay. Clockwise, when looking from the stern, okay, the direction is given. If the ship is steering to the left on the curve of 100 meter radius is given as 100 meters, and the speed of ship is given as 36 kmph. 36 kmph. What is the gyroscopic couple? Yeah, then the gyroscopic couple is dash. He is not asking you the effect of gyroscopic couple. Directly we can calculate the magnitude of gyroscopic couple. Okay guys. So here gyroscopic couple is given by, this is again repeated question, that is C is equal to I times of omega into omega p. Okay, C is equal to I will be mk square, this will be mk square, and omega will be 2 pi n by 60 whole square, and omega p will be equal to v by r, that is velocity by radius. V by r it will be. So here mass is given to us as 3,500 kgs, 3,500 kgs into 0.45 square into 2 pi into n is 3,000 rpm. 3,000 by 60, okay, here square will not be there guys, square will not be there, okay. So into velocity, here V I need to express this in terms of meters per second. So this will be 36 into 1000 by 3600, which is equal to 10 meter per second. This is equal to 10 meter per second. Okay. So this will be 10 by radius. Turning radius is given as 100 meters. Turning radius is 100 meters. So 10 by 100. So upon calculating this, we'll be getting the answer as approximately 22,000, okay, Newton meter, or which can be written as 22 kilonewton meters. Okay, that is option A will be the answer. Option A will be the answer. Okay, next question. Yes, this is a question from the governor's topic. Yeah, consider the following statements regarding the governor. Statement A says that a Wilson governor is a spring-controlled governor in which the vertical arms of the bell crank lever are fitted with the spring balls. Okay. So here the bell crank lever in the Wilson governor, here there is, to these balls there is a spring connected. There is a spring connected. Okay. So we are connecting the spring to the balls, not to the bell crank lever. So statement A is false. Statement A is false. Next is in the Hartung governor. This is actually Hartung governor. Hartung governor. Hartung governor is a spring-loaded type governor in which two bell crank levers are pivoted to the two end arms which rotate with the spindle. You are pivoting the two bell crank levers at the end. No. Bell crank levers are pivoted at the intersection, the vertical arm and the horizontal arm where they are intersecting. At that point we are providing the pivot. At that point we are providing the pivot. So option, that is statement 2, will be also incorrect. Statement 2 will be also incorrect. Statement 3, in the spring controlled gravity governor, two bell crank levers are pivoted on the moving sleeve. Yes. In the gravity control to the sleeve, we are pivoting the arms. Okay. Statement 3 is correct. And statement 4 says that in a VAT governor, the pair of balls is attached to the spindle with the help of links. Yes. Even the statement 4 is also correct. Right. So the correct option will be statement 3 and statement 4. Statement 3 and statement 4, that is option B. Option B will be the answer. Okay. Next question. Yes. Consider the following statements regarding the gears. A cycloid is a locus of a point on the circumference of the circle that rolls without slipping on a fixed straight line. Yes. Statement 1 is correct. Statement 1 is correct. Okay. Next is hypocycloid is a locus of a point on the circumference of the circle that rolls without slipping on the circumference of another circle. Hypocycloid, for hypocycloid, the circle is going to roll on the inside circumference of fixed circle. Okay. So hypocycloid profile will be like this. So it has to roll inside. So this statement 2 is false. Statement 2 is false. Okay. That word inner circumference is missing. So statement 2 will be discarded. Next is statement 3. Epicycloid is a locus of a point on the circumference of the circle that rolls without slipping inside circumference. Inside circumference. This inside circumference corresponds to hypocycloid. For epicycloid, it will be outer circumference. Here the keyword should be outer. Okay. Keyword should be outer here. Outer circumference. Okay. So even the statement 3 is also wrong. Statement 3 is also wrong. So the correct option is, that is statement 1. Statement 1, that is option D is correct. Option D is correct. Yes. 2 and 3 are incorrect. Option D is correct. Right. So another question, this is from the vibrations. Yes. In the critical speed of light shaft having a single disc without damping, the critical speed of the shaft is, yes. Here we have a shaft supported in two bearings, okay, and carrying a rotor. So because of this rotor, the shaft is going to get deflected like this and like this. Okay. So the motion of the particles is perpendicular to the shaft axis. So here this will be equal to, here the critical speed of the shaft will be equal to frequency of natural vibrations for transverse direction, or lateral direction, okay. The particles are moving in the transverse direction, okay. So option C will be correct, okay. So I invite my colleague to take this discussion forward.
Okay, friends, welcome to RSE questions. Here we have question number 1. It is a problem. A hydrocarbon refrigerator operating on equal proportions of propane and isobutane by mass works on simple saturation cycle. Here the important point is the saturation cycle. That means at the end of compression, it is dry and saturated. The condenser and evaporator pressures are 14 bar and 1.4 bar. What is the approximate theoretical COP of the system? Take properties. H1 is equal to 545 kilojoules per kg. The data is given. Let us draw the TS diagram for this cycle. This is a vapor compression cycle. This is the vapor dome. So he is telling it is dry and saturated at the end of compression. This is state 1, state 2, state 3, state 4. This is constant pressure process. This is isentropic process. This is constant pressure process. This is isenthalpic process. Now let us see the data. Here he has given H1 is equal to 545 kilojoules per kg. Here is given H3 is equal to H4 is equal to 341.15 kilojoules per kg. And further he has given H2 is equal to 661 kilojoules per kg. This is the data is given. He is asking us to calculate what is the approximate theoretical COP of the system. So this is a TS diagram, H1, H3, H4, H2. This is because isenthalpic process. Now we want to find the COP. For finding COP, we require net refrigerating effect and work of compression. So let us calculate net refrigerating effect and work of compression. So net refrigerating effect is NRE is equal to H1 minus H4. What is H1 given? H1 is given as 545 kilojoules per kg. And H4 is given as 341.15. Again, 545 and 341.15. This is 545 minus 341.15. Now, we need not be very accurate here because we have to arrive at the answer without using a calculator. So let us take this, round it up to 342, or you round it up to 341, lower side. So this answer will be 545 minus 341. How much? This is 4, 0, 4, 0, and this is 2, 204 kilojoules per kg. Now let us calculate work of compression. Work of compression. Work of compression is equal to H2 minus H1. Now let us see what is H2. H2 is given as 661 kilojoules per kg. This is 661 minus H1. H1 is already written here 545. So this is equal to 116 kilojoules per kg. Now COP is equal to net refrigerating effect divided by work of compression. That is equal to 204 approximate value divided by 116. Now this is difficult to calculate without a calculator. So let us do a small jugglery. So let us write this as 232 minus 28 by 116. Or this is equal to 232 by 116 minus 28 by 116. Now you see COP. COP equal to 232 by 116 is 2. Now 28 by 116. So 25 by 100 is 0.25. So roughly it will be 0.25 if you see. So minus 0.25. So 2 minus 0.25 will be 1.75. This is an approximate calculation. This is not an exact calculation as per calculator. Now let us see the answers and find out whichever answer is closest to 1.75 will be our answer. Now going back, you see here, among the answers given, we have 1.8, 5.4, 3.6, 2.7. So answer is less than 2 is only one answer. Therefore, the right answer is 1.8. And this is closest to 1.75 our calculated value. Hence, the correct answer is A. The next question is, it is the performance test of an air conditioning unit rated as 140.7 kilowatts or 40 tons of refrigeration seems to be indicating poor cooling. The test on heat rejection to atmosphere in its condenser shows the following. Cooling water flow rate 4 liters per second. The density of water is 1 gram per cc. Hence, 4 liters per second equals 4 kgs per second. Water temperature inlet 30 degrees centigrade, outlet 40 degrees centigrade. Power input to the motor 48 kilowatts, 95% efficiency. What is the actual refrigerating capacity of the unit? This is a question asked. Okay, let us see. Cooling water flow rate. Cooling water flow rate m dot w is equal to 4 kg per second. 4 kg per second. Because the density of water is 1, hence 4 liters per second will give you 4 kgs per second. Next, water temperature at inlet and outlet. That is temperature difference of water, delta T water is equal to temperature outlet minus temperature at inlet, which is 40 minus 30, which is equal to 10 degrees centigrade. Okay. And Cp of water is equal to 4.1868 kilojoules per kg. Kilojoules per kg. And power input to the motor, power input is equal to 48 kilowatts. And efficiency is equal to 95%. These are data given. And he's asking, what is the actual refrigerating capacity? He's asking, what is the refrigerating capacity? Refrigerating capacity means the net refrigerating effect. Here we have to find out the net refrigerating effect. How we can find out net refrigerating effect? Net refrigerating effect is calculated by using the formula heat rejected minus work input. Heat rejected minus work input. Now, let us do the calculation. Now, net refrigerating effect. Net refrigerating effect in kilowatts is equal to heat rejected in kilowatts minus power in kilowatts. Now, how do we calculate heat rejected? Okay. Heat rejected is calculated by using the formula m dot w Cpw into delta T of water. So this is equal to m dot w Cpw delta T of water minus power input in kilowatts. Here has given power input with efficiency. So actual power input will be more than this. So power by efficiency. Power by efficiency. Now m dot w is given as how much? 4 kgs per second, 10 degrees, 4.1868. And this is 48 and 95. 4 into 4.1868 into 10 minus 48 by 0.95. Now this is a problem which requires calculator. Now let us try to solve it without using a calculator. So this can 4 into 10 is how much? 40. This can be written as 4 into 40 plus 40 into 0.1868 minus 48 into 100 by 95. Now, what is 4 into 40? 4 into 40 is 160 plus 4 into 0.1868. You need not be very much exact here. You can take 40 into 0.18. 18 fours are it is around 7.2. 40 into 0.18 is 7.2. I'm not being very exact here, I'm rounding off. Plus 7.2 minus 48 into, this one is 95 is 1 plus 5 by 95. Or this will be 167.2 minus 48 into 1 plus 1 by 19. Okay, 1 by 19, 1 by 20 is how much? 0.05. If you divide by 20, you'll get 0.05. But you're dividing by 19, you will get slightly more than 0.5. So it will be 167.2 minus 48 into 1.052, roughly. I need not be exact here, small calculations. Okay. Now, so net radiating effect is 167.2 minus 48, 1.052. It will be roughly 2.5. You can exactly take it as 2.5 or 2.5, 2.6 like that. 167.2 minus 2.6. No, sorry. Minus 48 plus 2.6. 2.6 will be 50.6. 50.6. Or this will be equal to 167.2 minus 50.6 is how much? 117. So it will be roughly 117 kilowatts. Or this is equal to, because this is net radiating effect, we have to express it in tons. So 117 by 7 by 2, or 117 by 7 into 2. 117 by 7 is how much? (17 into 2) is equal to roughly 34 kilowatts. Now let us see the answers. Here we have done an approximate calculation. We have not done a calculator calculation. So let us see what is the answers given. The answers given are 34.7, 52.6, 45.6, 48.6. The closest answer is what? A, 34.7. So this is a method you can follow for doing a problem without using a calculator. Okay. Now let us go to the next question. So this is another problematic question asked in refrigeration and air conditioning. 100 kgs of ice at -5 degrees centigrade is placed in a bunker to cool some vegetables. 24 hours later, the ice has melted into water at 10 degrees centigrade. What is the average rate of cooling in kilojoules per hour provided by the ice? Take specific heat of ice as 1.94 kilojoules per kg Kelvin. Specific heat of water as 4.1868 kilojoules per kg Kelvin. And latent heat of fusion of ice at 0 degrees centigrade is 335 kilojoules per kg. So here we have determined cooling rate. Cooling rate means we are determining net refrigerating effect in kilojoules per hour. Kilojoules per hour. This is in 24 hours. Cooling of vegetables is done in 24 hours. Now here, mass of ice. Mass of ice. Mass of ice is equal to 100 kg. 100 kg. Now it is at minus 5 degrees centigrade. Ti minus 5 degrees centigrade. And TO is 10 degrees centigrade. Okay. Time is equal to T is equal to 24 hours. 24 hours. And CP ice is equal to 1.94 kilojoules per kg Kelvin. And CP water is equal to 4.1868 kilojoules per kg Kelvin. And latent of ice 335 kilojoules per kg. This is the data that is given. Mass is given, inlet temperature is given, outlet temperature is given, time is given, CP ice, CP water, latent of ice, every data is given. Here we have to calculate the cooling rate in kilojoules per hour, not in kilowatts. Please note that. So here, first, ice at minus 5 degrees centigrade. Freezing point of ice is 0 degrees centigrade. That need not be told. You have to assume it. Minus 5 to 0 degrees centigrade, it is converting ice to ice at 0 degrees centigrade. Then afterwards, you further add heat at constant temperature. Ice gets converted to water at 0 degrees centigrade. Then you want to further heat it, you have to add heat to water. And all this happens in 24 hours. Whatever is the heat absorbed by ice will be the heat removed from the vegetables. That means it is the net refrigerating effect. And he's asking about that only in kilojoules per hour. So there is no need to do any conversion of time here. You can use the time as it is. Now, let us do the heat absorbed by ice. By ice is equal to NRE, which is equal to mass of ice into CP ice delta T ice plus latent heat of ice plus CP water into delta T water. This is a net rejecting effect. Now let us see what is the mass of ice given? 100 kgs. What is CP of ice? CP of ice is 1.94. 1.94. You are heating ice from minus 5 to 0. That means delta T of ice is how much? 5 degrees into 5 plus latent of ice is given as 335 plus CP of water 4.1868 And you are heating it by how much? 10 degrees into 10. Now, let me tell you, we need not be very exact. Don't bother about decimals. Let us round it off to 2. So this will be 100 into 2 into 5, 10 plus 335 plus this is 41.868. 4.1868 into 10 is 41.868. You take it as 42. Nothing is going to happen. 42. Now this is how much? 335 plus 42. 377. 377 plus 10. 387. 387 into 100. This is kilojoules. He's asking cooling rate. So let us assume this is Q, cooling rate. Is equal to Q by T. Here T is time. Or this is 387 into 100 by time. 24. 387 100 by 24. Now 24 will get cancelled how much in 100? Roughly 4 times. Let us assume 24 4s are 96, is it not? Let us forget about the difference. 4 times it gets cancelled. 4 into 387. So 7 4s are 28. 4. 4 3s are 12. 12 plus 3. Now you see, the answer we got here is 1548 kilojoules per hour. Is it not? Now let us check the answers. We have not done an approximate, we have done only an approximate calculation by rounding of the figures. Okay. If you do the actual calculation, you will get the perfect answer. But this is by doing without a calculator we are doing. So let us compare the answer we got by approximation with the given answers. The given answers are A 1611, B 1811, C 1711, D 1911. The closest answer is 1611. Hence the answer is A. Now let us go to the final question. 27th question. An ammonia ice plant operates between a condenser temperature of 35 degrees centigrade and an evaporator temperature of minus 15 degrees centigrade. It produces 10 tons of ice per day from water at 30 degrees centigrade to ice at minus 5 degrees centigrade. Assume simple saturation cycle. What is the capacity of the refrigeration plant? Take specific heat of ice is 1.94 kilojoules per kg Kelvin. Specific heat of water is 4.1868 kilojoules per kg Kelvin. Latent heat of fusion of ice at 0 degrees centigrade is 335 kilojoules per kg. Here also is asking the net rejecting effect. Okay. But here he is asking in kilowatts. When he is asking in kilowatts, we have to convert in, we have to take the mass flow rate as kgs per second. Kgs per second. Now here you see. Now mass of ice or mass of water is equal to how much? 10 tons. That is 10 into 1000 kgs. Okay. Per day, time is equal to 24 hours. 24 hours. Temperature of water, initial temperature T, 30 degrees centigrade. Final temperature, outlet temperature, -5 degrees centigrade. Data given, CPI is 1.94 kilojoules per kg Kelvin. CP water 4.1868 kilojoules per kg Kelvin. Latent of ice is equal to 335 kilojoules per kg. What the examiner has done here is, he has given lengthy questions for you, time-consuming questions. I advise you, don't do a numerical in the initial stages of solving the paper. First, you finish off all theoretical questions. Then only you start attempting numerical questions, because numerical questions consume time. Okay, if you consume lot of time on numerical questions in the initial stages, it will be a loss to you, because many of the easier questions which are there later, you will not be able to concentrate upon. Hence, my sincere advice to all the students is, don't attempt numericals in the first 1.5 hours. You attempt only numerical hours questions after the 1.5 hours. It will build up your confidence and it will help you do the exam better. Please remember this. Okay. Now here also is asked only capacity of refrigeration, net refrigerating effect. He is asking in only in kilowatts. Only in kilowatts. So here he is cooling water from 30 degrees to -5 degrees centigrade. 30 to 0 degrees centigrade is one step. We are removing heat. 0 degrees centigrade water to 0 degrees centigrade ice. Next stage of heat removal at constant temperature, where we apply latent heat. Then 0 degrees centigrade to -5 degrees centigrade, again sensible heat. Sensible heat, latent heat, sensible heat. So we take 3 components here and we proceed with the problem. So here, net refrigerating effect, NRE, in kilowatts is equal to MW by T. Always remember, he's asking in kilowatts, so T should be in seconds, into CPW into delta T of water plus latent heat of ice plus CP of ice into delta T ice. Now let us substitute the values. Mass of water, how much? 10,000 kgs. 10,000 kgs. How much time? 24 hours. But you should not take in hours here. You should take in seconds. So multiply by 3,600. CP of water, 4.1868 into delta T. What is the initial temperature of water? 30 degrees centigrade. Till it becomes 0 degrees centigrade, you have to cool it. So the change in temperature is how much? 30. Plus latent heat of ice. How much is latent heat of ice? 335 kilojoules per kg. Plus CP of ice, 1.94. And change in temperature of ice, 0 degrees centigrade ice to -5 degrees centigrade ice, which is 5 degrees, into 5. Don't bother about fractions. Let us get an approximate answer and let us compare the approximate answer with the given answers. So whichever answer matches, that will be the right answer. This is without using a calculator. This is 10,000 by 24 into 3,600 into 4.1868 into 30. That is 42 into 3. 4.1868 into 0 is 42 into 3. 42 into 3 is how much? 126 plus 335 plus 1.94 into 5 is given. Let us make it 2. No problem. We are getting an approximate answer and comparing it to the nearest answer. We are doing small approximations here. Plus 10. $335 plus 136. 35 plus 36 is 77. 300 to 400. 35 plus 36, 71. This is 10,000 into 471 by 24 into 3,600. 335 plus 126, 435. 435 plus 26, 461 plus 10, 471. Okay. Now you see, this is 24. This is 471. So 471 by 24 approximately is 20. The answer will be slightly less than 20. This is less than 20. Sorry. Slightly less than 20, but closer to 20. Slightly less than 20, but closer to 20. Now, 2 zeros gets cancelled. 100 by 36. 100 by 36 is approximately how much? 100 by 36 is 36 into 3, 108. It is 100. Okay. So it is slightly less than 3. Slightly less than 3. Now, 20 into 3 is how much? 60. So this is equal to less than 60 will be the answer. So many kilowatts. Less than 60 should be the answer. Now let us compare the given answers with the answer, approximate answer we got. So the answer is, our approximate answer with higher rounding off is 60. So the answer should be less than 60. All the answers, if you compare, only one answer is less than 60. Therefore, the right answer is A, 54.43 kilowatts. I request all the students to adopt this method whenever big calculations are there. I once again advise them, don't do a numerical in the first 1.5 hours. Don't do a numerical in the first 1.5 hours. Try to attempt numericals only in the last hour of the exam. First 2 hours you devote for solving as many theoretical questions as possible. This will make you crack the examination in a better manner. All the best.
Let's start the remaining RAC questions. Right. See, first question is the use of single refrigerant. See here, single refrigerant is used, means it is not a cascade refrigeration. 2 refrigerants are not used. Okay? Now, single refrigerant in a simple vapor compression cycle. Here cycle is given, simple vapor compression cycle. Let me draw this cycle first. See, simple refrigeration cycle is given. Let us say TS diagram. Right, and this will be the liquid vapor dome. And let us say this is the compression. This is the condenser, then throttling and evaporator. This is a simple refrigeration cycle, right, VCR cycle. Then they have mentioned that for the cycle, for the production of low temperatures, we have to produce low temperatures
is limited by the following reasons. Now, out of these 3 reasons, which are the valid reasons that we have to identify to limit the lowest temperature? Means here, the lowest temperature is evaporator temperature, this evaporator temperature T, right? See, if I want to go for lowest temperature, I have to decrease this evaporator temperature. And as it is a refrigerant, it is a circulating in the cycle. And let us say, if this evaporator temperature falls below freezing temperature, then definitely refrigerant is going to freeze and it is of no use, right? Therefore, the first option, solidification temperature of the refrigerant, yes, it is a limit. Above that only we have to work. Then extremely low pressure in the evaporator. See, if evaporator temperature want to decrease, if the 4 dash and it is a 1 dash, right, this point, right, then evaporator temperature will decrease. Then definitely pressure is going to decrease, evaporator pressure is going to decrease, and at low pressure, the specific volume is very high. So second point they have mentioned, extremely low pressure in the evaporator and large suction volume. Yes, definitely, very low pressure and at that there is a large suction volume. Yes, it is also correct, right. And next is very high pressure ratio, therefore a low coefficient of performance. See my dear, as here in this case, evaporator pressure is decreasing, but condenser pressure is still same. Means pressure ratio is obviously increasing, and whenever pressure ratio is increasing, then definitely volumetric efficiency is decreasing, going to decrease, right? And here, see, initially refrigerating effect was this, and now this. Means refrigerating effect is decreasing, right? And work of compression, initially 1 to 2, but now 1 dash to 2. Means work of compressor, power consumed by the compressor is increasing. That means work consumed increase, and net refrigerating effect decreasing. So performance decreases, coefficient of performance decreases. So my dear, here they have mentioned very high pressure ratio, at very high pressure ratio, definitely performance is going to decrease. Right, this is also correct. Means all 3 are correct. Here 1, 2, 3, option D will be the correct choice. See, next question is exactly similar. But here what they have done, in the first question they have decreased evaporator pressure. Right, but in second question, similar question, they have increased condenser pressure. Obviously, as here you can see, consider the following statements in the vapor compression system. It is observed that an increase in condenser pressure is increased. You have questioned this, and keeping evaporator pressure constant. So again pressure ratio is going to increase, right? Again pressure ratio is going to increase. That means again all effects will be same. If pressure ratio is increased by increasing condenser pressure or by decreasing evaporator pressure, the effect will be same. Same diagram is valid. Work of compressor, that is power consumed, is going to increase. Refrigerating effect is going to decrease. COP, performance, is going to decrease. And because of increasing pressure ratio, volumetric efficiency is going to decrease. So let us observe a decrease in refrigerating capacity, that is net refrigerating effect, and increase in power consumption, yes, work of compressor. But here they have mentioned an increase in volumetric efficiency. No, volumetric efficiency is going to decrease. This is the wrong. Therefore, 1 and 2 only correct, right? 1 and 2 correct. Option C will be the correct choice. Okay. Now next question. See, which of the following principles and processes involved in the production of low temperature are correct? We have to produce low temperature, right? See, first is adiabatic demagnetization. See, demagnetization means decreasing the magnetic field. Magnetic field is decreased means energy is decreased, and temperature is a function of energy, or energy is a function of temperature, vice versa, right? As energy is decreasing, temperature is going to decrease. And my dear, adiabatic demagnetization produces very, very low temperature, right? Yes, it is correct. Then thermoelectric cooling. Thermoelectric cooling means thermoelectric refrigeration, which functions on the Peltier effect. Again, we are going to get very low temperature, right? Then reversible adiabatic expansion, irreversible adiabatic expansion of real gas. See, here they have mentioned adiabatic expansion, and we have seen, you can check the notes also, adiabatic expansion always gives cooling effect, whether it is reversible or irreversible. Means here both are correct. Both are correct. Therefore, all the options are correct. Therefore, 1, 2, 3, 4, all are correct. Option D is correct choice. Next, which one of the following is used in aircraft refrigeration? See, in aircraft refrigeration, we are using Bell-Coleman cycle. And Bell-Coleman cycle is nothing but reverse Brayton cycle. And Brayton cycle is an air cycle, my dear. Right? Therefore, here you can say gas, or air is a gas. Therefore, gas cycle refrigeration. That is Bell-Coleman cycle. Option B is a correct choice. Next, which one of the following is a designation for the dichloro. See what chemical formula they have given. Dichloro, Cl2, right? Tetrafluoro, F4, and ethane. Means here there will be 2 carbon atoms, right? And this formula, this chemical formula you must remember or you must know, right? From here you have to start. This is the chemical formula they have given, and they are asking what will be the designation, right? See, we know that we have formula that is CmHn FpClQ. This is our formula, right? So my dear, compare here. Carbon atoms are 2, M is 2. There is no hydrogen atom, therefore N is 0. There are 4 fluorine atoms, therefore P is 4. And chlorine atoms are Q, that is 2. Therefore Q is equal to 2. And chemical formula is written as, or designation is written as R M minus 1 N plus 1 P. This is how it is written. Therefore see R M minus 1, 2 minus 1, 1. N plus 1, N is 0, 0 plus 1, 1. And P is 4. Therefore it is R114. You can check, option A is correct choice. Now next question, see, which of the following are highly explosive and flammable in a refrigeration system? See, highly explosive are hydrocarbons, right? Whenever carbon and hydrogen are there, they are very highly explosive because of hydrogen. See, first is methane. Methane is hydrocarbon, that is CH4. Then next is butane. Butane is also hydrocarbon, that is C4H10. And as number of hydrogens are increasing, it is becoming highly explosive, right? They are definitely highly explosive. Then R134, it is environment friendly. It is environment friendly. And the chemical formula is C2H2F4, right? Now it is environment friendly, it is not that much explosive, right? Therefore, whenever hydrogen atoms are more, it is more explosive. Here there are 10 hydrogen atoms, therefore it is the most explosive. But my dear, we have to go for combination. If there is only option 2, definitely it is more explosive, right? But here, see, it is also hydrocarbon. These are the 2 hydrocarbons. Therefore, these are 2 very explosive, 1 and 2. Therefore, option B is correct choice. Okay. Now, I invite my another colleague for explanation of other questions.
Hello everyone, I am Ravi sir. Here I am teaching the production subject. Now see the solution of that production questions. Total 7 questions are asked in ESE 22 prelim examination. Now see the first interesting question what is given here. In the following process, if VR is the velocity of roller surface, that is surface velocity of roller, and we denoted by only V. Here it is denoted by VR, right? V0 is the velocity of material at the entrance, means velocity before rolling. Means here is a roller, 2 rollers are there, and before that what is the velocity is known as V0 to the deformation zone, and V1 is the velocity of material at the exit, means velocity after rolling is given, that is V1. What the values are given here? V0, here velocity is V1 and VR is surface velocity of roller. Then what is the formula here? You can see very simple question. Then what is forward sleeve? What is the forward sleeve? There are 2 sleeve, forward and backward. What is the formula of forward sleeve? Only option C, that is V1 minus VR divided by VR into 100. You have to write that answer in percentage. That simple question is over. Now see the next question, which is on metrology, right? Now see, which of the following feeds used for high strength assemblies? High strength assemblies means what? Permanent assemblies. If you have to make the permanent assembly, then what type of feed will be? The feed is interference feed. Is there option interference? No. Interference feed is also known as press feed, or it is also known as force feed. This is the answer. But what about that remaining 3? Light drive feeds, that are the normal, means that we can remove that assembly. But what is meaning of high strength assemblies? That assemblies are permanent assemblies. Means we have to fit that assemblies with a high force which will not remove later. But in that 3, there may be the possibility of that assembly may remove. That's why, what is the answer? Force feed, press feed, or we can also say as interference feed is the correct answer. Now see the favorite topic, that is metal casting question. Which of the following is the projection on a pattern? How the projection is provided on the pattern?
you can see that this is the pattern. Just see the pattern here. You see, I am giving the projection, not protection, projection on the pattern. You can see that. This is the pattern. I am writing here only P. This is the pattern. By taking this pattern, we have to make the mold. And when we will make the mold, you will get such a type of casting cavity. You will get such a type of casting cavity. Yes, just see the casting cavity, we got it here. And from here, what they asked, which one of the following is the projection on the pattern that is used to make recess in the mold to locate the core, means to place the core. Here we will place the core. Here we will place the core. Now you can see that I'm removing that core now. And what is the recess, man? Just see. This portion is what? Recess. Yes, and what is this part is known as core print. Where is the question? Option is B. Very, very easy. No sprue, no gate, and no riser. Now see the next question. Yes, again, nice question they asked on casting. What they asked? Which one of the following is the disadvantages of permanent mold or gravity die casting? Yeah, just see, all four are the advantages. Just see, this is also fast rate, production rate is more because permanent die is there. It is not like a sand casting. In the sand casting, you have to make the mold of sand. For each component, you required each mold. One component, one mold. 10 component, 10 mold. But here what is happening in the permanent mold, in one component, we can produce the number of casting, 100, 200, 500. That is a fast rate production can be attained with the permanent die casting. That is advantage. The process requires more labor. Wrong. The process does not require more labor. Now we can just see. Yes. Next. Good surface finish. Yes, in the permanent mold casting, we are good surface finish. But what is asked? Disadvantage of permanent mold. Yes, all are the advantages. Require less labor. Advantage. What is the disadvantage? Here we can think somewhat. In the some cases, we doesn't require. Just see, this is the mold. And here we are pouring the molten metal. Here we are pouring the molten metal. What happens when we are pouring the molten metal? This mold is at room temperature. And here molten metal has higher temperature, then there may be fast cooling. And because of fast cooling, what happens? This outer surface may get hard, which does not require in some casted component. That's why we can write that this is advantage for some casting process. Otherwise, that four are the advantage, but it may be disadvantage where we need uniform strength and hardness throughout, but in some cases it is not allowed. Hence, this is the outer harder and inner soft. That's why the answer is A. Now see the next question. Very nice. Which one of the following is formed due to large friction and stronger adhesion between chip sand tool face? Just see the tool. Just see the tool. Yes, which of the following formed due to large friction and stronger adhesion between chip and tool face? If there is a high friction between the chip and tool, just see the chip is traveling like this. If there is a high friction, heat generate will be more, and some workpiece particle, some chip particle will stick to here, will adhere to here, and one built up edge is formed. This built up edge is formed on the tool, and here we are getting the continuous chips. So what is the answer? Continuous chips with built up edge. Chapter is metal cutting question was there. Now see the next question. Yeah, again metal cutting. Which one of the following is the angle between the planes of end flank immediately below the end cutting edge? Just see, immediately below the end cutting edge, that angle is end relief angle. Yes, below, immediately below the end cutting edge and lying perpendicular to the base metal and right angle to the axis. No need to read that all.
It is very easy. Below the end cutting edge, there is only one angle, that is end relief angle. Yes, now the solution of that production questions are over. Now, my colleague will come here to give the solution of next subject.
Hello everybody, let us look at some questions from fluid mechanics. The question is asked from hydraulic machinery. Question says, consider the following statements regarding torque converter. A torque converter is a modified form of fluid coupling, which is the correct option. A reciprocating pump is used in torque converter, which is wrong answer. Therefore, the answer over here is option A. Option A alone will be correct over here. Let us move further. This is a question which is a combination of dimensional analysis along with hydraulic machinery. It says that a 1/4 scale model of a pump was tested in a laboratory at 1000 RPM. So N of model is equal to 1000. The head developed and the power input at the best efficiency point were found to be 7 meter and 25 kilowatt. Fine, these are all for model. What is the speed of the prototype if the prototype pump has to operate against a head of 36 meter? 36 meter over here happens to be the value for prototype. So now I can write over here D into N is proportional to root over of H, which implies diameter model upon diameter prototype multiplied to N model upon N prototype is equal to root over of H model upon H prototype. So what do we have over here? dm by dp over here is scale ratio, that is 1/4. N of model is equal to 1000. And NP is what we have to find out, is equal to root over of HM is given as 7 meter and HP is given as 36. If you calculate the value of NP, if you calculate, comes around 560 units. Let us look at the closest answer. Answer is B, 567 RPM. Moving further, the question says, consider the following statements regarding Euler turbine equation. The axial component produces a bending of shaft which is taken by the journal bearing. A wrong statement. Axial force does not create a bending of shaft. Next, the axial force only can cause the rotation of the runner. Again, a wrong statement. You don't require axial force for rotation, you require tangential force for rotation. Now you realize over here option 1 and option 2, both of them are wrong answers. Anywhere I see option 1 and option 2, I'll eliminate them. I see option 1 and option 2 over here. I see over here. What I'm seeing 2 over here. You have to use elimination technique. By that we get answer 3 and 4 are correct. So straight away, without reading those things also, I can straight away say 3 and 4 are correct over here. Moving further. Which one of the following turbines is most popularly used for medium head? No need to move further, think further. Straight away you can say Francis is medium in everything. Be it discharge, be it head, be it power produce, anything, medium is Francis. Moving further. Turbine to flow direction you have to match. Let us look at Dirichlet turbine is something which is not as popular, so you can look for the others. Propeller turbine is something like Kaplan turbine, so it is supposed to be an axial flow turbine. So B would go with 3. Francis is a mixed flow turbine, so I'm having 1. Pelton, the most famous turbine, 2. So this has to be 4. So the code is 4312. 4312 I see over here. Option A is correct. Moving further. The Kaplan turbine plant produces 2000 kilowatt under a head of 8 meter while running at 100 RPM. The discharge is 250 meter cube per second. The tip diameter of the runner is 6.5 meter and the hub to tip ratio is 0.43. This is a ratio given to you over here. What is the flow ratio based on the tip speed? Now, based on tip speed, the flow ratio is given by Kf is equal to Vf upon root over of 2GH. And Vf is equal to discharge upon pi by 4 into diameter of the tip square minus diameter of the hub square. Now, if you calculate this value, this comes out to be 4 into Q is 250 upon pi times diameter of the tip is equal to how much? 6.5. 6.5 square minus 6.5 into 0.43 square. Let us take 6.5 square aside, 1 minus 0.43 square. Now, these type of calculations will take some time, so I would rather recommend you to go for approximation. If you look for this approximately, it comes out to be 9.25 meter per second. 9.25 meter per second. Now, take this value of 9.25, put over here. So I'm having 9.25 upon root over of 2GH. Now look at the spacing in the options. It is a quite good spacing based on the base value. Let us take the base value of 0.43. I'm having a decent spacing over here. Based on the spacing, I can go for approximation, take G as 10, H is given as 8. So if you calculate this value, root over of 160 over here, root over of 160 is approximately 12.5. 9.25 divided by 12.5, approximately 75%, 0.73 is the value. Moving further, the water in a jet propelled boat is drawn amid ship and discharged at the back with an absolute velocity of 15 meter per second. The boat speed is 30 kilometer per hour, converted into meter per second. So the boat speed is equal to 30 into 5 divided by 18. 30 by 18 is 5 by 3. 30 into 5 by 18, it is 5 by 3, 25 divided by 3 meter per second, 8.33. The cross-sectional area of the jet at the back is 0.03 meters square. What is the efficiency of jet propulsion? Efficiency of jet propulsion, if you remember, it is equal to the thrust multiplied to the velocity of boat upon change in kinetic energy. Change in kinetic energy. So imagine the boat is something like this. Okay, you are having a pump over here. Let us say the boat is traveling in this particular direction. It is drawing water from here at a velocity of V1. It is issuing of water over here at a velocity of V2. Now the value of U and V1, both of them are same. They are equal to how much? 25 by 3 meter per second. And V2 is the velocity. V2 is not the actual, it is not the absolute velocity. It is a relative velocity we have to take. Okay. So the value of V2 would be equal to how much? It is equal to 15 plus 25 by 3. It is equal to 15 plus 25 by 3. If you take LCM, it is 3. So you can have 45 and 25 would make it 70. 70 by 3, let us say. This is the value of V2. Now let us look at this formula. The thrust over here is equal to how much? It is equal to m dot multiplied to V2 minus V1 multiplied to U upon change in kinetic energy is equal to half into m dot into V2 square minus V1 square. I can write V2 square minus V1 square as V2 minus V1 multiplied to V2 plus V1. I can cancel off m dot V2 minus V1, m dot V2 minus V1 over here. So I'm having U upon, or let us say 2U. It is 2U upon V2 plus V1. V2 plus V1. That is equal to 2 into 25 by 3 upon V2 is equal to 70 by 3 plus V1 is equal to 25 by 3. So it makes it 95 by 3. So this is equal to how much? 50 by 95. Or let us say 10 by 19. 10 by 19 is very, very close to 0.5, slightly more than 0.5. Look at the options over here. 51% is the best option. Moving further. In a double acting pump, the work saved by fitting air vessel is about. It's a direct question. The answer is 39.2%. Moving further to the next question. A single acting reciprocating pump. This has come even in civil paper also. Has a bore diameter of 200 mm with a stroke of 0.3 meter and runs at 45 RPM. The suction head is 8 meter. The delivery head is 20 meter. What is the theoretical discharge? These things are not required for all those things. If the slip is equal to 12%. He's asking theoretical discharge, but we have identified that they have not given any option relevant to theoretical discharge. They have given only options relevant to actual discharge. Let us anyway calculate. The value of Q theoretical has to be equal to area of piston or plunger, you can say, multiplied to stroke length multiplied to n divided by 60. That is equal to how much? Pi by 4 into diameter square into L into n divided by 60. Put in the numbers. The numbers over here are pi by 4 multiplied to diameter over here is equal to how much? 0.2. 0.2 square, 0.35. N over here is equal to 45 RPM divided by 60. If you calculate this value, this comes out to be nearly 8.25 liter per second. 8.25 liter per second. But since I don't see 8.25, I'm assuming that they're asking the actual discharge. There might be a printing mistake. Okay. So what I can do over here is I can say Q actual has to be equal to 1 minus slip percentage multiplied to Q theoretical. That is equal to, slip percentage is 12%. So 1 minus slip would give me 0.88 multiplied to Q theoretical is 8.25. 8.25. You can go for 0.9 multiplied to 8. 0.9 multiplied to 8 would be 7.2. The answer would be option A over here. Moving further. Now this is a very direct question. Okay. The friction coefficient, in friction coefficient, the boundary layer thickness the local friction coefficient at a location X and Reynolds number Re in a turbulent flow on a flat plate is given by how much? This is the option, standard option for laminar boundary layer. This option might be correct provided the numbers over here, the powers over here are 1 by 5. It is given as 0.5. This is again wrong. This happens to be correct option. This is again wrong. So option C is correct. This is a direct value. We have seen this value in the notes always. Moving further, the question says, now we are coming to fluid mechanics, basics of fluid mechanics. It's a question on buoyancy. The question says a body of dimensions 1.5 meter cross 1 meter cross 2 meter weighs 1962 Newton in water. This happens to be apparent weight. What is the weight of the body in A? The actual weight he's asking. Now we know that apparent weight has to be equal to actual weight minus FB, which implies actual weight has to be equal to apparent weight plus FB. So apparent weight is given to me as 1962. 1962 is basically 981 multiplied to 2. So what I'm doing over here is I'm going to assume throughout that the value of G happens to be equal to 10. Because again, look at the options. If the options are very widely spaced, take some assumption. Okay, help yourself. So now this value, instead of taking 1962, I'll take 2000. 2000 plus FB is equal to gamma of fluid multiplied to volume. Gamma over here, I'll take as 10,000 for water, volume is equal to 3. So this value is 30,000 plus 2,000, 32,000. Any number close to 32,000? Yes, we see over here 31,392. Very close. Take that as answer. Option A. Moving further, a question from kinematics. Look over here. The question says the following cases represent the velocity components. V is equal to, that is y component of velocity is 2y square. W is equal to 2xy. What is the third component of velocity? That is u is equal to how much he's asking. To satisfy continuity equation, I have to make a standard assumption over here. And the assumption is the flow happens to be incompressible. If it is so, then dou u by dou x plus dou v by dou y plus dou w by dou z has to be equal to 0. If so, you see over here, dou v by dou y is equal to how much? It is equal to 4y plus dou w by dou z is equal to how much? 2xy plus dou u by dou x has to be equal to 0. Now push this on the other side, it becomes negative. And since it is having 4y, if I integrate by taking dou x over here, it becomes 4xy with a negative, x square y with a negative, plus a function of y and z. So 4xy with a negative, xy square with a negative, function of y and z. Option A is correct. Moving further. In an open circular tank, 20 centimeter diameter, 100 meter long, contains water up to a height of 60 centimeter. The tank is rotated about its vertical axis at 300 RPM. Fine, N is given to you. What is the depth of the parabola formed at the free surface? So this is a question on forced vortex motion. We know the formula for H is equal to R square omega square divided by 2G. Let us look at the value of omega. Omega has to be equal to how much? It is equal to 300 RPM multiplied to 2 pi divided by 60. So 2 pi n by 60. Now 300 by 60 is 5. 5 times 2 is 10. 10 pi. This becomes 10 pi. I'm again going to make some assumptions because I see the options are decently spaced. So I can say R over here is equal to 20 centimeter diameter, that is 0.1 square. Omega is equal to how much? 10 pi. 10 pi whole square multiplied to 2G. 2G. Now look over here. G I'm taking as 10. Pi is 3.14. Square nearly 10. So I'm having 10 power 10 square and 10. And I'm having this thing. So this becomes 10 square is 100 into 10 is 1000 multiplied to 0.1 square is 10 by 2 times 10. So this becomes approximately 1.2. Approximately 1.2. Look at the options in meters. So this is 50.28 centimeter. That will be the correct answer. Moving further. What is the velocity of flow at a radius of 0.8 meter if the water is flowing radially outward in the horizontal plane from a source whose strength is equal to 12 meters square per second. So imagine you are having a source over here from which water is issued out, fluid is issued out at a distance of how much? Radius of 0.8 meter. What is the velocity is asking? Fine. So how do we get this value? The value of velocity is equal to source. Strength of the source is basically discharge per unit feet perpendicular to the surface. So Q upon circumference, that is 2 pi r, which is equal to, Q is equal to 12, divided by 2 times pi times r is equal to 0.8. Calculate this value. This comes out to be 12 divided by 1.6 into pi. 12 divided by 1.6 into pi. You can say 12 divided by 1.6 into pi. 1.6 into 3.14. Approximately 5. Right? 3 into 1.6 is 4.8. Okay? 4.8 says 5. It's not a big distance. So 12 by 5 is nearly 4.8. Look at the options close to 4.8. Option is B. Moving further. A pitot-static tube is used to measure the velocity of water in a pipe. The stagnation pressure is 6 meters, static pressure is 5 meters. That means dynamic pressure is equal to 1 meter. What is the velocity of flow assuming that the coefficient of tube is equal to 0.98? That is CV he has given. Look at the options. Well spaced. Consider CV is equal to 1. G is equal to 10. I am not taking this thing. G is equal to 10 I am taking. Right. Options are very widely spaced. So what is the value of velocity? Velocity has to be equal to CV root over of 2G multiplied to H dynamic. H dynamic. CV I'm taking 1, G I'm taking 10. So I'm having root over of 2 into 10 multiplied to H dynamic is equal to 1. That H dynamic is basically 6 minus 5. Root 20. Root 20 is supposed to be between 4 and 5. Look at the options between 4 and 5. Option D is correct. Don't calculate. Go logically. Move further. A fluid of viscosity 0.7 Pascal and specific gravity 1.3 is flowing through a circular pipe of diameter 100 mm. The maximum shear stress is given by 196.2. Again, a multiple of G you're seeing. What is the pressure gradient of the flow he's asking? If he takes multiple of G, I'll consider it nearly 200. Nearly 200. Okay. We know the formula for tau maximum or tau naught. Wall shear stress, it is minus dP by dx multiplied to R by 2 or capital R by 2 you can say. I want the value of dP by dx. I realize it is going to be negative. So dP by dx is equal to minus times tau naught divided by R. That is equal to minus 2 times 200 divided by R is equal to how much? R kitna hai? How much is R? R is equal to 0.05. 0.05. Now if you look at this value, jump 2 places over here, 200s over here. 5 ones are 5, let us say 4,000. 2 times 4,000 is going to give you 8,000. Any number very close to 8,000 and a negative sign. Option is B. Moving further. An oil of viscosity 10 poise flows between 2 parallel fixed plates which are kept at a distance of 0.05 meter, 50 mm. What is the rate of flow of oil between the plates if the drop of pressure in length of 1.2 meter is equal to 0.3 Newton per centimeter square? He has given you delta P by L over here. He's asking you the value of discharge. Discharge is equal to how much? It is equal to 1 by 12 mu minus dP by dx or delta P by L multiplied to B cube into W. Now this was something which would take some time to calculate, but again option should help you. So 1 by 12 into mu is equal to how much? 10 poise, that is 1 Pascal second. Delta P is equal to 0.3 Newton per centimeter square. That is going to be 0.3 into 10 power 4, or let us say 3000 divided by L is equal to 1.2. B is equal to how much? 50 mm. That is 1 by, that is 50 mm, right? 50 mm is equal to 1 by 20, I can say. I can say 1 by 20. 1 by 20 cube multiplied to width is equal to how much? 0.2. Width is equal to 0.2. Now you can simplify this thing. If you simplify this thing, you are going to get, let us say, you have over here, this is 1 this is 0.6 0.6 So you are having 3000 divided by 8000. That is going to be 3 by 8. 3 by 8 into 0.6 and 12 will give me 7.2. 7.2. 3 ones are 7.2, 2.4. 1 divided by 8 into 2.4. 1 divided by 8 into 2.4 is the answer. If you calculate this value should come out to be nearly 5.2 liter per second. Is it? 1 divided by 8 into 2.4. 8 into 2.4 will give me how much? 8 into 2 is equal to 16. 0.4 will give me 3.2. 1 by 19.2. 1 by 19.2 is approximately 1 by 20. 1 by 20 is going to give me 0.005. Okay, this value is correct. 5.2 liter per second is correct. Moving further. Now, this question would take a lot of time. I am assuming if anyone was smart enough, he was not attempting this question at all. Okay, attempting every question is never the criteria. The question says, a shaft of diameter 0.35 meter rotates at 200 RPM inside a sleeve, 100 mm long. The dynamic viscosity of the lubricating oil is equal to 2. In a 2 mm gap between the sleeve and the shaft is 8 points. What is the power lost in the bearing? Now, power lost in the bearing or power required to overcome the losses is supposed to be equal to the force by the virtue of viscosity or shear force multiplied to velocity. Shear force is equal to shear stress multiplied to area shear multiplied to velocity. This is equal to mu into du by dy multiplied to area shear is equal to how much? It is equal to pi dl in the case of a shaft rotating inside a sleeve or a bearing multiplied to velocity. Again, you can say mu into du by dy is basically velocity at the shaft minus velocity at the bearing. That is going to be v only upon dy. dy over here is equal to 2 mm. I'm assuming linear variation. So I'm having over here v into v will give me v square by dy is equal to the, let us say thickness is t multiplied to pi into d into L. Okay? Again, you calculate this thing further. This becomes mu into. Now, he has given me RPM. Okay, velocity is equal to pi dn by 60. So if I put over here pi dn by 60, I'm going to get pi square. D square into d will give me d cube. Again, I can take one pi from here. So it has become pi cube. Pi cube d cube n square into L divided by t over here is 2 mm. This is t for me. T into 60 square. Now this was a very difficult numerical to solve. Concept very simple, but numerical solving extremely difficult over here. Anyway, I'm going to give you the answer. The answer comes out to be 0.59 kilowatt. Okay, you can solve this thing. It might require a calculator for you. Moving further. Now, this is a question which can be easily solved provided you know a formula of settling velocity. The question says a sphere of diameter 2 mm falls 150 mm in 20 seconds in a viscous liquid. The density of the sphere is equal to 7,500 kg per meter cube, and of the liquid it is 900 kg per meter cube. What is the coefficient of viscosity of the liquid? Take acceleration due to gravity as 9.81. Again, should I take it? Let us look at the options. Options are decently spaced. I'll take it as 10. Okay, don't accept everything he says. Think logically. Right. Now, how do you answer this question? To answer this question, you know the formula for settling velocity. Settling velocity is equal to 1 by 18 mu density of the solid minus density of the fluid multiplied to g times d square. If you know the formula, you can solve it very quickly. Otherwise, you'll have to go for deriving this particular formula, which would take some time. Now, I want mu, so take mu on the other side. You are having 1 by 18 times velocity, density of the solid minus density of the fluid multiplied to g times d square. Ab velocity kitna hai? How much is velocity? You see it is falling 150 mm in 20 seconds. That is displacement time. So divide over here. Displacement by time is going to give you 7.5 mm per second. This is the value of velocity I'm having. So I'm going to write over here 1 by 18 into 7.5 into 10 power minus 3. Density of the solid is 7500. Liquid is 900. So it is going to be 6600. G is equal to 10 for me. Okay, diameter over here is equal to 2 mm. That is equal to 2 mm square is 4 square into 10 power minus 6 in meters. Numbers are quite simple. Very simple actually. Okay, I can cancel 10 power minus 3, 10 power minus 6 and the 3 zeros over here. So it becomes 6.6 for me. Right, 6.6. I can cancel over here with 3. I get 1.1 over here. I'm not 4 square here, 2 square tha ye. It was 2 square. This becomes 44 upon 3 into 7.5. It becomes 44 divided by 22.5. 44 upon 22.5. 22.5 times 2 is 45. That means this value is nearly 2 in SI units. Nearly 2 in SI units is slightly less actually. Slightly less than 2. Slightly less than 2 in SI units is 20 poise. Anything very close to 20 poise, slightly less than 20 poise. 19.17 is the answer. Okay? Next. Now this question is saying center of pressure is calculated by using principle of moments. Many of you might not know what is principle of moments. It basically says that when anything is in equilibrium, the clockwise moments about a particular point are being balanced by the anti-clockwise moments. Even though it's a correct principle, but this is not being used in finding the center of pressure. What we use in finding center of pressure, if you remember the derivation, we have used something known as Varignon's theorem from your mechanics. Varignon's theorem. We have used this thing. We have not used principle of moments. So this is a wrong statement. Let us look at the statement 2. The moments of a resultant force about an axis is equal to the sum of moments of the components about the same axis. This is a standard definition for Varignon's theorem. This is perfectly correct. This is wrong. Statement 1 is wrong. Statement 2 is correct. I believe the answer would be answer D over here. Next question. A fire engine raises water at the rate of 6,000 liter per minute through a height of 2 meters and discharges it at 10 meter per second. The velocity is given, right? The HP of the fire engine is nearly equal to. When he says nearly, you take this also nearly, right? There's no harm in doing that. Now, what do? I can say the head of water when it is being discharged, it is being discharged into atmosphere. That means the pressure head is equal to 0. Only thing left with me is velocity head plus datum head. Velocity is equal to how much? 10. If I take G as 10, I'm having 10 square by 20, that is 5 plus 2. That means the total head is equal to 7. Power is equal to gamma into Q into H. I want the answer in what units? Let us first of all find out in watts. So I'm having gamma is equal to 10,000 because it is water. Q is equal to how much? What is the value of Q? 6,000 liter per minute. That is 6,000 divided by 60. That is going to give me 100 liter per second. That is 0.1 meter cube per second. And H we have calculated 7. So this makes it 0.1 cancels with 1 0, 7,000 watt is the value. 7,000 watt in HP is equal to 7,000 divided by 746. Now this value is supposed to be between 9 and 10. Look at any option between 9 and 10. Yes, I have one. It is 9.5. Always look at the options. They'll help you identify whether you can take some assumptions or not. And in this particular year, we have had so many assumptions being valid. Next question, a direct question from viscosity. A flat plate of area 1.5 into 10 power 6 mm square is pulled with a speed of this much relative to other plate located at a distance of this much from it. What is the power required to maintain its speed if the fluid separating them is having a viscosity of 1 poise? So you're having a plate, let us say this plate is fixed over here. There's a fluid present over here, you're pulling this particular plate at a velocity. Right. What is the power required is asking. Again, the same formula for power. Sometime back we have seen. Power is equal to shear force multiplied to velocity. Shear force is equal to shear stress multiplied to area shear. Velocity comes as it is. What is shear stress? Mu into du by dy. In this case, it is V by thickness T, let us say. Thickness T multiplied to shearing area multiplied to velocity. So I'm having over here. Mu is given as 1 poise, that is equal to 0.1. Velocity into velocity square. What is the velocity I'm having over here? 0.4. 0.4 square is 0.16. Area is equal to how much? Mm square and 10 power 6, both of them will cancel off. I'll get in SI units 1.5 divided by thickness is equal to how much? What is the thickness separating them? 0.15. 0.15 mm into 10 power 3. Now look at the numbers. 0.1, 1.5, 0.15 cancel off. This goes, minus 3 here. This goes on top. It becomes 0.16 into 1000. That is 160. Perfect answer, 160. Option A is correct. Next question. A pipe contains an oil of specific gravity 0.9. A differential manometer connected to the 2 points A and B shows a difference of mercury of 15 centimeter. Let me call it as HM. What is the difference in pressure between these 2 points? It should be between these 2 points. Take acceleration due to gravity again, 9.81. He keeps saying, I keep changing. For me, its value is 10. I look at the options, I decide 10. Specific gravity of mercury, 13.6 standard value. Density of water, standard value. Now, what is this question saying? You're having, let us say, a pipeline, another pipeline. You're having a manometer connecting them. The manometric fluid, let us say, is mercury. It has assumed some position like this. the difference between these two is given to you as how much? 15 centimeter, that is HM, which is equal to 15 centimeter. I have to find out the value of difference in pressure. I can convert this value into delta H star. And how do I do that? Delta H star for me is equal to HM multiplied to SM by SW minus 1. That is equal to how much? 15 centimeter is 0.15. SM by SW is mercury upon water. 13.6 upon 1 is 13.6 minus 1 is 12.6. This is the value of delta H star. Now the value of pressure would be equal to how much? Rho into G into delta H star. Now this time I have taken this value in terms of water. So rho for water is 1000. G for all intents and purposes is 10 for me. And the value of delta H star is equal to 0.15 into 12.6 into 12.6. So this becomes equal to, those 0 cancel over here. It is 15 multiplied to 115 multiplied to 1260. 15 multiplied to 1260, you can say it is equal to 12600, and half of this thing is going to be 6300. So this value would be 00918, 18900. Any number close to 18900? Option A. The only number close to 18900, and should be less than, because I have assumed a higher value of G. I should get an actual value lesser than the value I have got over here. That way the answer is option A. I hope you are getting this, and thank you.
Hello students, welcome to the power plant engineering. Dear students, out of 150 questions, 11 questions asked from power plant engineering. Among these 11 questions, 10 questions are very, very easy. The other question also easy, but that question needs a calculator. The smart students are doing that kind of question at last based on the time availability. Look at the very first question. It is given from the compressors. Look at the question. Surge is a condition which occurs, option A, in forward movement of the aircraft, option B, beyond the stable limit of operation. Yes, the surge is happening due to adverse restriction of the mass flow rate. It is like this. If I take the head versus mass flow rate, pressure head versus mass flow rate of the flow, the head capacity characteristic curve, 1 minute, the head capacity characteristic curve may be appearing like this. You know, A to B be the surging region, and this may be the C to D be the choking region. This may be the one of the stable operating region. This is the other stable operating region, but beyond the stable operating region or in this particular region, the compressors like centrifugal compressor and axial flow compressors are suffering with the surging phenomena. Anyhow, if the axial flow compressor or centrifugal flow compressor are operating beyond the stable region, the compressors are suffering with the surging. Therefore, option B is absolutely correct. I hope you got my point. Let us take the next question. Look at the next question. It is also the question from the compressors, asked like this. Consider the following statements regarding stalling. Stalling means the flow of gas layers away from the contour of the blade is called stalling. In axial flow compression, this is also for the axial flow compression. Look at the first statement. The flow separation occurring on the suction side of the blades is negative stalling. Absolutely wrong. Whatever the stalling which is occurring in the suction side is called positive stalling. Similarly, look at the second statement. The flow separation occurring on the pressure side of the blade is called positive stalling. No, it is also absolutely wrong statement, because the stalling which is happening in the pressure side or positive side is called negative stalling. Now look at the options. You try to opt other than the statement 1 and statement 2. 1 and 2 not correct. 2 and 3 not correct. 3 and 4 absolutely correct. Absolutely correct. 1 minute. And 1 and 4 this is also not correct. Therefore, third statement and fourth statement are absolutely correct. Anyhow, option C is absolutely correct option. I hope you got my point. Let us take the next question. This is the question connected to Rankine cycle or thermoelectric power plant. First, let me read the question. It is asked like this. Which one of the following statements is not correct? Is not correct regarding Rankine cycle. Option A, for the steam boiler, the ideal process would be a reversible constant pressure heating process. This is the correct statement, but you are asked to decide incorrect statement. Therefore, it is not my answer. Look at the option B. For the turbine, the ideal process would be a reversible adiabatic expansion. This is also correct statement, but that is not our option. Look at the option C. For the condenser, it would be a reversible constant pressure heat rejection as the steam condenses till it becomes saturated liquid. This is also a correct statement, but asked incorrect statement. Therefore, option D might be the incorrect statement. Let me read that question, that statement also. For the pump, the ideal process would be the reversible adiabatic expansion. No, the pumping is the pressure boosting process. The pressure boosting process are generally called as compression process. It is given for expansion. Therefore, option D is the incorrect statement. That is our option. Okay. Now let us take the next question. Which one of the following statements is not correct? You are asked to decide the incorrect statement. It is connected to the steam condensers or thermoelectric power plant. Look at the option A. In surface condensers, the cooling water and exhaust steam do not come in direct contact with each other. That is absolutely true statement, but you are asked to decide incorrect statement. In case of surface condenser, both cooling water and the steam available from the turbine are not directly mixing. The second statement, that is option B, the vacuum efficiency is the ratio of ideal vacuum to actual vacuum. No, the vacuum efficiency is the ratio between the actual vacuum and ideal vacuum. The ratio between the actual vacuum and ideal vacuum is the vacuum efficiency of the condenser. Look at the B. The vacuum efficiency is the ratio of ideal vacuum to actual vacuum. This is the incorrect statement. That is your option. Option B is absolutely correct. The problems are not easy. These are all very easy problems. Look at the next question. Try to read the next question. Which one of the following statements is not correct? Again, you are asked to decide the incorrect statement. Let us take the first statement. This is the problem connected to the steam boilers. Grate is the platform in the furnace of boiler upon which the fuel is burnt and it is made of cast iron bars. Yes, the surface over which the firing of the fuel takes place in the boiler is called grate. That is given as correct statement, but you are asked to decide incorrect statement. Option A is not correct. A is not correct means that is not our option. That statement is absolutely correct. Look at the second statement. The removal of the mud and other impurities of water from the lowest part of the boiler is termed as blowing off. This statement also called absolutely correct. The method of removing the mud from the boiler from the downside of the boiler is called blowing off process. That statement is correct, but that is not my answer. Look at the third option. A Cochrane boiler is one of the best type of vertical multi-tubular boiler. This is also correct statement. Cochrane boiler is the multi-tube boiler. Look at the last one. Babcock and Wilcox boiler is a fire tube boiler. No, the Babcock and Wilcox boiler is the natural circulation type water tube boiler. Therefore, option D is incorrect statement. That is my required option. Okay, look at the next question. Try to read the next question. It is a problem connected to again boiler. Which one of the following statements is correct? In water tube boiler, water surrounds the tubes and hot gases are inside the tubes. You are asked to decide the correct statement. In case of water tube boiler, water is flowing through the pipes and combust gas are flowing over the pipes. But it is given in water tube boiler, water surrounds the tube and gases are inside the tube. This is not correct statement. Okay. Similarly, look at the option B. The boilers which produce steam at a pressure of 10 bar and below are called high pressure boilers. No, the boilers which are producing the steam with a pressure around 10 bar are coming under low pressure boilers. This is also absolutely wrong. Look at the option C. Lancashire boiler is externally fired boiler. No, Lancashire boiler is coming under internally fired boiler. Therefore, option Lancashire boiler is externally fired boiler. The Stirling boiler, yes, absolutely correct. Absolutely correct. Lancashire boiler is coming under externally fired boiler. Therefore, option C is absolutely correct because you are asked to decide the correct statement. Okay. Similarly, let us take the next question. Look at the question which is required the calculator. Smart students are always doing this kind of problem at last because it is taking lot of time. Now look, let us take the question. The similar question was given in the last year also. It is given like this. In a power plant, the efficiencies of the electric generator turbine, electric generator efficiency 0.97, generator efficiency 0.97 and the turbine efficiency 0.95, turbine efficiency 0.95 and the boiler efficiency is given 0.92 and the cycle efficiency means thermal efficiency of the thermoelectric power plant or Rankine cycle efficiency given 0.42 and the last one overall efficiency of the plant is given 0.33. Overall efficiency of the plant is 0.33. Then what you are asked to decide, what percent of the total electricity generated is consumed in running the auxiliaries. First let us decide the auxiliaries efficiency. Here auxiliaries efficiency can be decided like this. Overall efficiency equal to the boiler efficiency multiplied by turbine efficiency multiplied by cycle efficiency multiplied by the generator efficiency multiplied by the auxiliary components efficiency. Here I know the overall efficiency is given, boiler efficiency also given, the cycle efficiency given, generator efficiency given and turbine efficiency also given. The unknown value is auxiliary components efficiency. You try to find the auxiliary components efficiency. Without calculator, it is quite difficult to decide the answer. Then what you are asked to find, what percentage of total electricity generated is consumed by running the auxiliaries. The percentage of the energy required, let me write somewhere here, percentage of the energy required for auxiliaries or for driving the auxiliaries. It is equal to 1 minus auxiliary components efficiency. Approximately the answer is 7.32. Option C is correct, but this kind of question is needed the calculator. Okay. Let us take the next question. So this is the question connected to the, let me read the problem. It is connected to the turbine, steam turbine. It is given like this. The question is given, an ideal cycle is impracticably, because that means why, it is asked why the ideal regeneration cycle is not practically possible. Option A, there is an ideal fluid available which is considered as working fluid, need not be. Option B, it is not possible to transfer heat of expanding steam to the fluid in the turbine itself. Absolutely correct. Dear students, the ideal regeneration cycle can be obtained by sending the condensate to the turbine itself for the purpose of heating the condensate or regeneration purpose. It is like this. If I take the only turbine, you know, the steam is entering to the turbine, the steam is entering to the steam turbine, that steam is becoming liquid called condensate by dumping the heat to the coolant available in the condenser. That condensate is pumped back to the turbine by means of a pump. This condensate is receiving the heat energy from the steam while the steam is expanding. It means the steam turbine has to do the dual functions. One is the steam turbine has to rotate and it should be acting as a heat exchanger for transferring the heat from expanding steam to condensate. That too, the ideal regeneration can be possible only by the time the steam is expanding, the temperature drop of the steam is equal to gain in temperature of the water. Anyhow, the ideal regeneration cycle is not practically possible because it is not practically possible to act as a heat exchanger right by the time the steam is expanding over the turbine blades. That means the turbine itself, right, cannot be acting as a heat exchanger for heating the condensate. That is the practical reason why the ideal regeneration cycle is not practically possible. Anyhow, option B is absolutely correct. Let me read the statement B again. It is not possible to transfer the heat of expanding steam to the fluid in the turbine itself. Turbine itself cannot be acting as a heat exchanger for regenerating purpose or heating the condensate. That is the practical reason why the ideal regeneration cycle is not practically possible. Okay, I hope you clearly understood. Let me take the next question. Look at the next question. It is the problem connected to the steam boilers. Match list 1 and list 2 kind of question. Lamont boiler, Loeffler boiler, Benson boiler, Velox boiler. Dear students, as we know, the Benson boiler is the supercritical boiler. The supercritical boiler is operating beyond the critical pressure. Among the given pressures, which is the critical pressure or above the critical pressure? Definitely 230 kg per cm square is the pressure above the critical pressure for water. Since Benson boiler since Benson boiler is coming under supercritical boiler, the Benson boiler is connected to 4. Similarly, the Lamont boiler is also coming under high pressure water tube boiler. It is developing the steam with a pressure around 170 bar. Anyhow, A2, B4. Look at the A2, B4. A2, B4 is not connecting. A2, 1 minute. A2, C4. A2, C4. Option C is absolutely correct because the Benson boiler is coming under supercritical boiler and a Lamont boiler is developing the steam around at a pressure of 170 kg per cm square. I hope you clearly got my point. Similarly, look at the next question. It is also connected to the Rankine cycle. The question is asked like this. Which one of the following statements is correct? You are asked to decide the correct statement, not incorrect statement. It is given like this. The Rankine cycle efficiency can be improved by increasing the average temperature at which heat is rejected. Absolutely wrong. Because in terms of mean temperature of heat addition and mean temperature of heat rejection, the Rankine cycle efficiency is equal to 1 minus mean temperature of heat rejection divided by mean temperature of heat supplied. Here Tm2 means mean temperature of heat rejection, mean temperature of heat rejection. Tm1 means mean temperature of heat supplied. From this, the Rankine cycle efficiency can be increased by decreasing the mean temperature of heat rejection or by increasing the mean temperature of heat supplied. But look at the first statement, the Rankine cycle efficiency can be improved by increasing the mean temperature at which the heat is rejected. This is not correct statement. Look at the second statement, that is option B. The Rankine cycle efficiency can be improved by decreasing or reducing the temperature at which heat is rejected. Absolutely correct. For the same mean temperature of heat supplied, if the mean temperature of heat rejection is decreasing, definitely thermal efficiency or Rankine cycle efficiency is increasing. This is the practical reason all thermoelectric power plants are maintaining better efficiency in the winter season than that of summer season, because in the winter naturally cooling water is available as a coolant at low temperature. Okay. Similarly, let us take the next question. It is asked like this. It is also matching kind of question. Boiler to turbine process, condenser to pump process, turbine to condenser process, pump to boiler process. Under list 2, reversible adiabatic expansion in the turbine. Generally, the steam is expanding in the turbine reversible adiabatically. But what it is given as a boiler to turbine process, indirectly based on the options or based on the list 2 options, it is asked what is happening with the turbine. Definitely, the steam is expanding in the turbine blades reversible adiabatically. Therefore, A1 is absolutely correct. Similarly, B, turbine to condenser process. It means indirectly what is happening in the condenser. In the condenser, what is happening? The steam is dumping the heat to the coolant at constant pressure. Look at the 2, constant pressure transfer of heat in the condenser. Absolutely correct. B2 is correct. Similarly, condenser to pumping process. What is happening with the pumping? During the pumping process, reversible adiabatically, the pressure of the material is increasing. That means reversible adiabatic pumping process. Look at the third statement, reversible adiabatic pumping process in the feed pump. Absolutely correct. C3 correct. A1, B2, C3, definitely D4. Pump to boiler. In the boiler, we are supplying the heat at constant pressure where the water is becoming steam. Constant pressure transfer of heat in the boiler. Absolutely correct. For C3, एक minute. D4, absolutely correct. D4. A1, B2, C3, D4. That is the correct answer. Look at the options available. A1, B2, C3, D4. Option D is absolutely correct. Similarly, look at the question which is asked from the refrigeration part. With that question, all the questions from the power plant completed. This is the question from the refrigeration, assertion and reason kind of question. Let me read the statement 1. The vapor absorption system uses heat energy to change the condition of the refrigerant from the evaporator. Absolutely wrong. Because of course, vapor absorption refrigeration system is the heat energy operated cycle. But that heat energy we are giving to the generator where the refrigerant, liquid refrigerant is becoming vapor refrigerant. The change of state or the condition of the refrigerant will be changing by receiving the heat energy from the generator location. Therefore, it is not absolutely correct. If assertion statement or statement 1 is wrong, definitely the reason statement or statement 2 or statement 2 is correct. For this kind of question, if assertion is wrong, reason is correct, or if the statement 1 is wrong, statement 2 is correct. Option D is absolutely correct. Anyhow, let me read the second statement also. The load variations do not affect the performance of vapor absorption system. Absolutely correct. The load variations can be affected with the vapor compression refrigeration system. In vapor absorption refrigeration system, the performance cannot be affected with load variation. With this, my part is completed. Now my friend will come to teach other concept, other topic. Thank you.
Hello friends, myself Sanmati Kurkute. I secured All India Rank 2 in UPSC examination 2020. So now today I will discuss about renewable energy services questions. So see here, which one of the following fuel cell has lowest operating temperature? So see here, out of the various types of fuel cell, so the correct order for the temperature is PPAMC. This is how we need to remember. Whereas P is proton exchange membrane fuel cell, and here is solid oxide fuel cell. So lowest temperature is proton exchange membrane fuel cell. So adjusting the nacelle about the vertical axis to bring the rotor facing wind is known as. So see here, this is just a simple definition of yaw control mechanism out of the total 3 control mechanisms available, like tether control, then one is the pitch control or blade pitch control, and yaw control. So this is just the definition of yaw control. So D is the correct choice. So in a distributed collector solar thermal electric power plant, the heat collected in collectors is used to dissociate ammonia into nitrogen and hydrogen at approximately. So they are asking what is the actual industrial use pressure. So first of all here ammonia. So to dissociate nitrogen and hydrogen, this is what they are talking about. So from my point of view, it is not expected from student to answer such type of questions because they are standard practices. Okay, so for this the answer is 300 atmospheric pressure. So next question is solar thermal water pumps works on. So see here, first of all we will see the choices given. So choices given are Rankine cycle, Otto cycle, Carnot cycle and diesel cycle. So these all are power producing cycles, and whereas in the question it is given that solar thermal water pump works on. So here in the question paper also they are using the word pump, but from my point of view the word should be plant actually. So solar thermal water plant works on. So the answer is simply Rankine cycle. Power plant works on Rankine cycle, thermal blaze. So this is just a SI engine operation. Carnot cycle is a hypothetical cycle, and diesel cycle is also CI engine cycle. So the next question is the concentration ratio of as high as 3000 can be obtained by. So here also various types of collectors, solar collectors are available to us. So out of that, the modified flat plate collector. Okay, modified flat plate collector is the lowest concentration ratio. After that, the compound parabolic collector. After that, cylindrical parabolic collector. One more here that is not available, that is paraboloid dish type collector. And highest concentration ratio in the range of 3000, 10,000 like that is obtained using central tower receiver. So this is the answer, my friends. The angle between the sun rays and its projection on horizontal surface is known as. So this is just simply simply from the terminology of the various angles related to solar. So suppose this is sun and this is our plate. Then they are asking about this angle, whereas this is this is altitude or inclination angle, and this is nozzle angle, zenith angle. Sorry. So they are talking about the sun rays and horizontal projection. So that is inclination angle is the answer. So total solar radiation received at any point on the Earth's surface is the sum of direct and diffuse radiation and is referred to as. So this is simply the definition of total radiations. So total radiation consists of two components. One is diffuse radiation and another is direct or beam radiation. So the answer is total radiations. So next is the rate at which solar energy arrives at the top of the atmosphere is called. See here, the top of the atmosphere, solar flux, is also called as extraterrestrial flux, or it is just simply the definition of solar constant. So C is the answer, whereas its value is 1367 watt per meter square. Consider the following statements regarding solar ponds. So first statement is, it is possible to produce electricity from solar pond by using a special high temperature heat engine coupled to an electric generator. So first of all friends, solar pond, the temperature range is 50 to 120 degrees Celsius. Okay, for this very low temperature we cannot produce power, whereas we can use it for other applications. So the first statement is completely wrong. Anyhow, they are showing that high temperature heat engine, but the temperature available itself is in this range. Okay, so this statement is false. So out of the given choices, see here the first statement is false, means the option, this B is correct. And we will see, just read down these two statements. So these are simply the description about the solar pond. Okay. Which one of the following is a vertical axis windmill? So it is just from the simple question from the classification of wind turbines. One is horizontal axis wind turbine and one is vertical axis wind turbine. So Darius type windmill is a vertical axis windmill. Okay, whereas these three are horizontal type. One more example from this vertical axis is Savonius rotor, that is not present here. Okay. So consider the following statement regarding solar radiation measurements. So they are talking about the instruments of solar radiation. One instrument is pyranometer and another instrument is periheliometer. Okay. So we know that from their basic principle, this pyranometer measures both beam and diffuse radiations or total radiations, whereas this periheliometer can measure only beam radiations. Okay, so from that only they are discussing. So pyranometer and here beam, which is wrong statement. Pyranometer, total hemispherical, this is correct. Periheliometer, beam, so correct. So 2 and 3 statements are correct, so correct answer is option B. Which one of the following materials used for heat collection element in parabolic trough plants of solar central receiver system? So see here the most common material is that usual we all know that copper, and it was a simple question. So mild steel is not used even. The option, you may be confused with this option, but aluminum is not used, it is reflector type. So here copper is the answer. So my next will be continued by for production season. Thank you.
So as we see in this question, right, the statement question is given here, right? So this question is concerned basically to the mechanization topic, right? So here in this statement one question is given that the mechanization means something is done by the machinery as well as the by hand, right? So we already discussed in the class itself, that is ESE online class. So where we discussed about the mechanization at the starting of the chapter itself, right? So from the mechanization only the automation has been developed, right? So where we will discuss about the mechanization is nothing but the something that process is done by the machinery, not by the hand. So basically this mechanization is used to reduce the human power. So this these efforts will be reduced with the help of the mechanical systems, or I mean to say the electrical systems. So here we are going to use the piston and cylinder type, or I mean to say the electrical motors, right? So from the given statement 1 itself, it's showing that the statement 1 is incorrect. That is, all right, 1 minute. So the statement 1 says that the mechanization means something is done by the machinery as well as the by hand, right? So the given statement is incorrect. So the option itself, by choosing the statement 1 is incorrect, so the correct option will be D, right? So the second statement is given, that is the mechanization of the manufacturing means milestone oriented trend towards minimizing the human efforts to extend its possibility by adapting the mechanical or electrical means or methods for automating the different manufacturing processes, right? The same thing we discussed in the ACE online class also, right? In the first chapter, at the time of mechanization as well as the automation topic, the same definition as given in this slide, right? So where we discussed about the mechanization process, after that we discussed about the automation concept also, right? So as we see as we move to the question, right? The correct answer for this question is that answer D, that is Delhi. I mean to say here the answer is Delhi, right? So as we move to the next question, right? So the same concept we discussed. So as we move to the next question, that is question number 121 in D set number, right? So the question is asked related to the microprocessor and the microcontroller, right? So here as we see the different statements are given, right? That is about the microcontroller as well as the address bus as well as the microcomputer, right? So the question is in front of you. So here the detailed solution is provided in the website, right? So as we move to the question, so here if you see, observe carefully the second statement, right? So the second statement is given, the address bus carries the signals relating to the control action. The second statement is absolutely incorrect, right? Incorrect, because here the control bus carries the signal relating to the control actions, right? So remaining two questions are, I'm not reading because of short time, right? So here as we see, the statement 2 is incorrect. So by choosing this statement 2, if you go for the multiple options, right? So where the 2 is given, this is also incorrect, and 2B also given, this is also incorrect, as well as we move to the D, this is also incorrect. The correct option is the C, right? So let's cross verify the key, right? So the correct answer is the C, whatever we have seen, right? So as we move to the same solution, that is as I said, the control bus, the signals relating to the control actions are carried by the control bus, right? So the next question we will see. So that is question number 122 in D set numbers, right? So the question is basically concerned to the microprocessor instructions, right? So here the different types of instructions are given, right? Such as, so as we see the compare instruction as well as the jump instruction and the decrement instructions, right? So after reading all these questions, they are asking about the correct statement, or I mean say the correct statement concerned to the microprocessor instruction, right? So if you read the complete question, right? So as we move on to the first statement, right? So which says that the compare instruction reads the content of a particular memory location and copy it to the specific register in the processor. The statement 1 is incorrect, right? So as we move on to the options, so by eliminating option, right? So first statement is incorrect, so the option A incorrect, and option D also incorrect. As we move on to the option C, it is also incorrect, right? So here the correct option concerned to this question is that option B, that is Bombay, that is 2 and 3, right? So let's cross verify the same key with the solution, right? So the option B is the correct one. So the same thing we have seen, right? So here, as I said, here the load instruction reads the load here, right? The load instruction reads the content of the specified memory location and that copies its specified register location in the central processing unit. The same thing is given in that is opposite to the first statement. So that's why the statement 1 is incorrect, right? So let's move to the next question, right? So as we move to the next question, that is 123, set number D, right? So the question is basically concerned to the characteristics of a transducer, right? So correct, they are asking the characteristics, or I mean say the specifications concerned to the sensor or transducer, right? So if you read the options, right? So basically they are asked about the basic definition concerned to the characteristics, or I mean say the static characteristics concerned to the sensor or transducer, right? So they are asked about the definition concerned to the span and the precision as well as the sensitivity as well as the hysteresis, right? So after reading all these options, I mean say that is the span and the precision as well as the sensitivity and the hysteresis, right? So the correct statement concerned to the static characteristics of a transducer, it is that the precision, right? See here, the precision is defined as the degree of exactness in which the instrument is designated or intended to perform, right? So the correct answer concerned to this question is that option B, Bombay. Let's cross verify the same thing, right? So this is the option B, right? So whatever the other options are given, such as the span and sensitivity and hysteresis, are incorrect statements, or I mean to say the definitions are incorrect concerned to the characteristics concerned to the sensor, or I mean to say the specifications concerned to the transducer, or I mean to say the sensor, right? So as we move to the next question, that is 124 in D set, right? So the question is basically concerned to the dynamic quantities concerned to the transducer, right? So here the basic definitions are given, the concerned to the characteristics of the sensor or transducer, right? Such as the overshoot definition is given, as well as the transient, as well as the steady state periodic, right? So as we read the basic definitions concerned to the dynamic characteristics of a sensor and the transducers, all statements are correct, right? So whatever the definitions are given, that is overshoot, as well as the transient and the steady state periodic. So all the given statements are correct, right? So the correct option is that Delhi. That is 1, 2, 3 are correct statements concerned to the dynamic quantities in sensors and the transducer, right? I hope it is clear, right? So let's cross verify the same key, right? So that answer is the D, right? So this one, right? So as we move on to the next question, that is 125. So here basically this question is concerned to the encoder, right? So we have different types of encoders, right? So such as we see the basic definition is given, that is encoder, and the second statement is concerned to the digital optical encoder, right? So the second statement is concerned to the digital optical encoder, and the third statement concerned to the incremental encoder, right? So they are asking the correct statements concerned to these three statements, right? So they are asking the correct statements. So as we read these statements 1, 2 and 3, all three statements are correct concerned to the encoder, right? So these are the correct statements concerned to the different types of encoders. The correct option for this one is that, I mean say the statement 1 is correct, and 2 and 3 also, right? The correct answer concerned to this one is option D, that is 1, 2, 3. Let's cross verify the same key, right? So as we move on to the key, the correct one is D. So here the given all statements are correct, and here all the correct statements are regarding the encoder only, right? So as we move on to the next question, which is as I can say, here the statements are given concerned to the accelerometer, right? So the questions are the question is concerned to the accelerometer. So where we have a different types of accelerometers are given in options, right? So those accelerometers are, the first one is the displacement seismic accelerometer, right? The second one is the strain gauge accelerometer, right? So as we move on to the third one, the potential accelerometer, and the option D is concerned to the LVDT accelerometer, right? So if you read all options, so in case of the D option, that is concerned to the LVDT accelerometer. So where the question, the statement says that the LVDT accelerometer consists of one primary and 4 secondary windings which are placed on either side of the center core. So as we see, as we recall the basic concept concerned to the LVDT accelerometer, so where we will be having the one primary coil and 2 secondary coils, right? So so here whatever the statement is given, that is D option, is incorrect, right? So the same thing they are asking in the question also, right? That is which of the following statement is not correct regarding the accelerometer, right? So that is nothing but the incorrect one, right? Incorrect one. All right. So the correct answer for concerned to this question is D, right? That is Delhi. So let's cross verify the same key, right? So as we move to the key here, that is D, as I said. So as I said, the same thing here. The LVDT accelerometer consists of one primary coil, right? So where we can see the one primary coil, and the second one is we have 2 secondary coils, right? So here we have 2 secondary coils. The same thing is given in the solution also. The LVDT accelerometer consists of one primary and 2 secondary windings, right? Sorry, not coils, it's winding, which are placed on either of central core, right? All right. So as we move on to the next question, that is 127, I can say, right? So here 127 question number in set D, right? So here the question concerned to the valves, right? That is control valves, I can say, right? So let's read the question. Which one of the following valves restrict or throttle the fluid in a particular direction to influence the volumetric flow of the fluid, right? So here as we see the correct statement concerned to this one is that is flow control valve, right? So which is used to control the fluid of a system, right? Let's cross verify the same thing, right? So here the option B is the correct one, as I said, the flow control valve, right? So the same, the best example concern we can see the gate valve, right? So which is used to control the fluid in one direction or both direction, right? So as we move on to the next one, right? So here basically there are asked about the different types of instructions, right? So let's read the question number 128. So which one of the following instruction is conditional instruction which allows the user to change the order in which the processor scans the program, right? So the correct answer concerned to this question is that control instruction, right? So let's cross verify the same question, right? So here the answer C is the correct one. So which is basically the control instruction or the conditional or output instruction which is allowed the user to change the order in which the processor scans the program, right? So basically this control instruction is used to to reduce the time, I can say, right? Or to minimize the scan time, right? So and create the more efficient program as well as and provide the diagnostic programming tools to facilitate the troubleshooting, right? So this is the correct answer concerned to the 128, that is control instruction. Perfect. So as we move on to the next question, right? So here basically this, if you read this 129 question, that is which one of the following signals are external commands signals provided to the controller, right? So this basically this question is concerned to the control systems, right? Basically this question concerned to the control systems, right? So here as we move on to the subtopic, I can say, right? So this question is again related to the closed loop type of control system, right? So where we are going to give the set point signals, right? Set point signals are external commands which is provided to the controller, right? So here the correct answer concerned to this one is the D, that is set point signals. So let's cross verify the answer along with the diagram. So the answer is the answer is the D, I can say, right? So where we can see the set point signals are fed to the here the external commands signals are provided to the controller, right? So as we move on to the next question, that is 130, I can say. So it is basically the question is related to the precision movements of a robot, right? So here the question says that which one of the following is the smallest increment movements into which the robot can divide its work volume, right? So which is work volume is also known as the work envelope, right? We already discussed the same topic. The same topic we discussed in ESE Online also, that is in the classroom, right? So where we discussed about the precision movements of a robot, right? So here as we move to the question, right? So it is asking that the smallest increments of movement into which the robot can divide its work volume, right? So the correct answer concerned to this question is that spatial resolution of a robot, right? So here the answer is the spatial resolution of a robot, right? The same definition as given. So here the same concept we discussed at the time of ESE Online class. So that is the spatial resolution. So where we discussed about the spatial resolution definition as well as the factors which will be going to influence the spatial resolution, right? The two factors we also discussed, right? That is system control resolution as well as the mechanical inaccuracies, right? In detail we discussed. So as we move on to the further next question, I can say, right? So that is about the 131 question number, right? So which is basically concerned to the sensor type of question, right? So here as we see the question, which one of the following sensor is a special type of force sensor composed of matrix of force sensing element, right? So here the question clearly saying that the sensor which is used to measure the forces, right? So here the question is clearly saying that the measurement of the force of a system, right? So here the options are given. the touch sensor as well as the tactile array sensor as well as the range sensor and the proximity sensor, right? So range sensors are not used for the measurement of the forces as well as the proximity sensors also not used for the measurement of the force, I can say. As we move to the touch sensor, so basically whether the object has been touched by the robot or not, that will be known by the touch sensor. But here in this case of touch sensor, we are not going to calculate any forces, right? We are not going to calculate any forces. So that's why we are thus given option A is also incorrect, right? So whereas if you take the option B, that is tactile array sensor, right? So basically which is used to measure the forces, right? Measure the forces by using this tactile array sensor. The correct answer concerned to this question is that option B, Bombay, right? All right. So as we move to the next question, that is the last question I can say, right? So this question concerned to the robotics, right? So basically this question says regarding the robot end effector, right? So here the robot end effector which are we have seen the same thing in the ACE online class also, right? So here the robot end effectors are basically classified into the two categories. One is a gripper and second one is a tool, right? So here as we see different types of grippers are given. First one is the magnetic gripper and the second one is the hooks and as well as the scoop and ladles, right? The same statements are given in front, statements are there in front of your board, right? So here the different types of grippers are given. So here the first statement it says concerned to the magnetic grippers. Basically these magnetic grippers are used to handle the ferrous objects from one place to the another place, right? So as we move to the hooks type, so which can be used to handle the I can say to handle the containers parts from moving from one location to the another location, right? So as we move to the third statement, right? So the scoops and the ladles, right? So in the scoops and ladles are basically used to lift the powders or liquids from one place to the another place, right? So here what are the three statements are given? All three statements are correct concerned to this question, right? So they are asking the same thing, that is correct statements concerned to the robot end effector, right? So the correct option is that option D, that is Delhi. 1, 2, 3 are all statements are correct, right? So that is answer is Delhi. Let's cross verify. Same thing is D, right? So here the given all statements are correct concerned to this question. So this is the end of the solutions concerned to the mechatronics and robotics. And I would like to say thanks to here what are the topic we have seen end effector. So the same topic we have seen in the ACE online also, right? So where we discuss about the in robot anatomy, right? So where we discuss about the manipulator as well as the robot end effector, right? So this is for your information. So as we move on to the final slide, that is I can say all the best for your results. Thank you.